and all the stuff in.
Are we muted? Not
Are
on
we
my
muted?
end.
I don't know.
No, we're not muted on my end, so we should be out there. Again said stream is muted.
Oh, bloody hell, my bacon wasn't even cooking. Christ's sake.
Judy's going audio. Okay, why?
Audio.
I've got audio in
You
the...
blew all their...
Hey?
Did you blow all their eardrums by
Again
playing
said
Skippy?
stream is muted. No, I hear audio coming through YouTube.
I hear you. I don't mean to listen to me.
Oh, bloody hell, my bacon wasn't even cooking.
Yeah, see?
Yeah, I get audio on my end.
Yeah. Like, they're just a bit slow out there.
Oh, she says it's okay now.
Yeah, it should be caught up by now. Bit of a delay. So...
Well, I mean, she shouldn't see anybody lighting up and then hearing the audio later. If that's the case, there's definitely something wrong.
What did you put out there? Yeah, I can hear audio, no problem. You're in here.
I know. I'm out there as well.
So who's SP?
Yeah, who is SP?
Have we got a clue for that yet?
Not yet.
SP.
No.
SP. 4 letters. And you said Sean, maybe. SE.
No, that was just me. That was just me being silly.
Oh, yeah. Name?
He's an American.
Okay.
Oh, that narrows it down. It's American to a few billion people.
He shared the Nobel Prize.
Oh, another one.
In physics.
Okay. Yes. There's not many names I can think of with it.
With an S.
Shared a Nobel Prize in physics as an American.
Yes.
If it's 3 letters, I would have said Sir somebody, but obviously
no,
4
is
some
prick.
Well, not if he's an American, he wouldn't. No, wouldn't be a sir, would he?
I suppose you want a clue. I will give you a clue then. There you go. There's your clue.
Okay. Today's scientist is an American astrophysicist who shared the Nobel Prize in Physics for providing evidence that the expansion of the universe is accelerating.
Can you tell us who he shared the Nobel Prize with?
No. Another guy?
Yeah, that's useful, thanks. You could have just said no. Would have been easier.
Does some person fit? Oh, not enough letters. No.
Well, it's funny. I was listening to a lecture by Neil deGrasse Tyson and he was talking about the expansion of the universe just yesterday. It's interesting. But can't think of the name, what the name is at all.
I think you got people stumped. Where's Clive when we need him?
Yeah.
I do strongly believe in Newton's first law of motion as well. Definitely.
I could tell you that he shared it with an Australian. Well, US Australian.
Hey, Timbo Turtle's got it right. And he said he cheated, of course.
He's an Aussie. He's an Aussie, was he?
No, this
No.
guy wasn't an Aussie.
No, he
It wasn't
shared
an
it with
Aussie.
an Aussie.
Well, US Aussie.
US. But what? Hang on. US Aussie.
How does that
An
work?
American that shared it an American Aussie. Well, not Australian,
Yeah.
American, whatever. I don't
An
know.
Aussie American.
Well, since they're probably working together, obviously he's living in the US, but came from Australia at some point.
Need help, Peanuts?
Why is Scott mentioning Jim BR1? Why is he
Oh
mentioning
yeah,
his name?
that's a name, Scott.
It is. Doesn't
That's a
fit
name.
though.
That's a name.
Scott with one T.
Might be. I've seen Scott with a 1T. Not usually, but I have seen it.
I think if it was Scott with one T, it would be Scott No Brains.
You got to think Old Testament, New Testament.
Yeah. You better call.
Nobody in the Peanuts is getting there.
Yeah, I thought
Getting it?
Carl
No,
might
I
have
have
a
no
go
idea.
at it. Carl?
I might get that one.
I'm not going to cheat. So
Nah.
Hint for the first name. You better call.
better call Soul.
Ooh. Paul.
Soul, not Paul.
Mm. You cheated ahead of time. I don't think that's cheating. I think that's perfectly legit, Carl. I have enough trouble remembering my own name, let alone other people's names. So.
Cheated ahead of time.
I call Heisenberg. Boom.
Well, come on, out with it, Carl.
Okay,
right
you know
back.
who it is.
Just got to check on my bacon.
Well, Sol's the first name.
Starts with P. It's P. Ooh, close. Yeah, that's pretty good.
Pearl Nutter.
It's close.
Close.
Very close.
Pearl Nutter. That's his crazy brother.
Yes. Less nutting and more mumbling.
Anybody got it yet? No.
Carl is very close. You need to sort of join his stuff together.
What's that name?
Truth Nerd said, I guess
Pearl-
the first
Pearl-
name correctly.
Pearl Nutter.
No idea about the last name.
Pearl Nutter. What?
Not Pearl Nutter. Very close, but not Nutter.
No, I'm just reading what Carl's put. That's a Pearl Nutter.
This, I said less nutting and more mumbling.
Yeah. Pearl Isner. No.
Peterson.
You're just
Okay.
guessing at names now, aren't you? You're not figuring it out at all. You just firing some names out there just to see if it fits.
Yeah. Yeah, I'm just picking it up and throwing it at the wall and see what sticks.
Plum pudding.
I thought he was getting further away. Underwatch. I tried.
Perchy twirler.
Pearl Whirler. Pearl the Whirler.
Pulitzer, is it? Like as in Pulitzer Prize.
Pulitzer Prize. That would be a
Pulitzer.
surprise.
That fit? Looked.
I don't know. Perli.
I'm too lazy to too lazy to count the number of dashes.
Yeah, I think you might be. I think you might be a letter short. If it's...
Oh my. Okay.
It's actually quite a good story. There were two teams working on the same goal, and they were sort of like trying to race each other to get the truth out there. See who could publish the result first. And obviously, Saul's team won.
Oh, so it is Sol.
Yeah,
and
we've already
it's
figured
Saul,
that.
Yeah,
Yeah, sold somebody.
and Carl just got one letter in the surname wrong.
Oh, really?
It's
One
not-
letter.
It's not Pearl Nutter.
Pearl Mutter, as in M.
Pearl Mutter is it? Yes.
There you go.
Saul Pearl Mutter. Yeah.
Perlmutter. Okay.
Pearl Mutter. Yeah.
Well,
Sold
probably
Pearl Mutter.
probably spelt pronounced Mutter. Pearl Mutter, probably.
Oh,
Sounds like a German name. Ish.
Saul. I think so.
No, the surname. I mean,
No, I meant because it's called Saul, so I suspect it's
well,
German origin.
Oh, was Soul German origin? I don't think so.
No, I'm thinking
Now, if Rumpus was to meet this man, he would go up and say, "How's it going, Saul Pearl Mutter, 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 Mutter."
Matter.
Oh,
Very
M2M
good.
just dropped a video. China on the moon.
Yeah, I timed it so it was scheduled to release when the show is beginning.
Cool.
Well, since you're late, and it's answering one of Timbo's
Well, I was going
questions.
to say, I was going to say that sounds like a really good idea to do a video on that.
Yeah, yeah, it was a good one actually. Yeah. Yeah.
So, did anyone watch MC Toon's funeral of the incoherent dielectric?
Yes,
acceleration?
I did watch
Yeah,
it last
this-
night. That was
Yeah.
good. I watched some of it.
quite
Yeah,
good.
I listened to it. I
yeah.
listened to it. Yeah.
Oh dear.
That sounds like something I didn't catch. So
That Brian, he's a clever guy, isn't he?
It's okay. Yeah.
He's good.
so which
Still
video?
suffering from the idea that you could actually use logic to talk to flat earthers, but you know.
So which video is that
That's
one?
all right.
Tune done.
This afternoon there'll be but you would have got a notification. I think it's already hit Discord, didn't it?
Yeah.
Well, it should have came up
I mean,
in.
that Bryant Myers, he's a channel you should watch. Actually, he actually knows his physics quite well. So, unlike many other people, he gets it right.
Yeah, and he's not. His manner of speak is actually quite good. I thought he's able to.
Gets pretty much straight to the point without dilly dallying around.
Yeah,
Yeah.
Well, it didn't drop in.
But not sort of- but also not trying to sort of make it sound like, yeah, I know all this and you know nothing either. It's sort of like, oh,
Yeah.
I'll have to go to Toon's channel to get that one. Is it on Toon Live?
it's in there.
'Cause
It's
it
in
didn't.
our chill your stuff.
I think
No,
so.
I just
yeah.
looked.
Yeah, it is. It's up.
Yeah.
I can see it there. It's got the date of yesterday at 6:02.
Tombstone with
R.I.P.
R.I.P.
Oh yeah, I was already there. I thought you said this afternoon.
Well, that's when I watched it.
No.
Oh,
But some
No,
of
it-
Bryant's other debunks of what Whitsett was saying are a lot shorter and sort of
it would have been. It would have have posted the notification yesterday at 6, and then
Yeah, I've got
the
that.
actual
So FE debate
stream
versus
was
Kel
today.
Beta or something.
Hmm.
Okay. I'll grab
So-
that for in a minute. Obviously, if you've watched it, you can help me out with the timestamps. Oh, room fundle. There, is that the same link? Yeah. Oh, look what I found. You know who dropped a video? A recent one.
What? Someone starting with L? It could be a girl's or a boy's name.
Yeah. What's Shady sharing his screen for? Posting stuff over there. What's he doing? What do you want us to see that for, Shady? You DMing Jin. That's a bit of a risk, isn't it? I was just looking at the part that Jin wrote. It's like an essay, and Shady's just replying with a couple of words. Okay, he's missed Lindsay's for a couple of weeks now, I think, guys out there in the peanuts. And he's got his whiteboard back and everything. And it's nothing on it. It's blank. Lindsay with the... Well, it's got a couple
Blank
of...
whiteboard?
Well, it's got a couple of numbers or something written up on the top,
Wow.
but the rest of it's blank on the whole screen. What's he starting afresh, is he?
That is unusual, that he starts with a blank whiteboard.
Yeah. Maybe he's going to say I was all wrong. It's all a globe.
Yeah, disclaimer, yeah. Oh, we'll put it on Lindsay speed. DM me if anyone wants to play with Jin. No, I don't think we want to play with him.
Nah.
You have your fun, Crumpy. Okay. Well, I'm ready, I think. Got everything ready.
I can map out
Come on, Matt, do
Lindsay's
your
room
job.
from the reflections.
Oh,
Matt,
yeah.
Are you there?
I don't know.
I'll do it.
I was eating.
There he is.
So I was eating. Had a mouthful. Terry,
Oh, yes, Matt.
do you want to press play?
Yes, I could do that for you, but just for you.
No, that's all right.
No one else, only because you asked.
Oh, right, okay.
Welcome everybody, welcome to my site, which is called Flat Earth Philosophy. It's all about flat earth, and a lot of it's based on ancient philosophy that confirms everything that I have myself discovered through modern technology, namely a camera, star trail photography. I'm about to blow the lid on the globe. I've got 5 examples that destroy the spinning ball globe model. There's no point in me doing a paper because it's against the narrative. It's against the lies that the Jesuit Freemason order have over the people. It's mind control. All run from the top, Vatican, royal family, they're all in on it. It's Freemasonry. Not the average little Freemason at the bottom here thinks he's a gentleman. He's got no idea what's happening up there. But I'm here to show you, to vindicate all flat earthers. So this is at least 4 Nobel Prizes if it was with the narrative. I'm never going to get one. So if any of you flat earthers want to donate all the work I've done over the last 3 years, because I haven't even spent a lot of time and money on this thing, you can email me and I'll send you some details.
Is this a recent
I'm quite
video?
happy to accept some money.
Yeah.
I mean, this is recent.
Oh, it's recent, is it? Oh, okay.
I'll fire ahead and get it out
So
there,
if you
share it
donate
far
to
and
each
wide,
page,
get along to your
you'll
school, show your headmaster, teacher, scientist, whoever, who like to push the narrative, push the lies that they were parented to, so they can parent it to your children, and get them to explain these 5 examples, what's going on. It just proves 100% you did not live on a spinning ball.
Oh, it's
So
proof,
let's start
you're
with
saying,
Orion's belt.
Not evidence, it's proof.
No, not evidence.
Now, it's all to do with photographies. Nighttime photography, okay? Now, I'm going to show
know about
you
photography?
from a southern hemisphere perspective what I'm seeing in photography. So I'm in the south, and in the distance I can see the northern horizon, and that's all centered on Polaris, right? But over my head,
I was seeing
No, I can barely see what he's drawing.
Over my head. If I'm dead north to south on a meridian, that's my meridian. Every man has a meridian north to south on the flat Earth, on our flat Earth model. And on a dead north to south meridian, if you're in the southern hemisphere, you will have a star trail rotation around Sigma Octantis. Okay? Centered on
It
Sigma
doesn't look
Octantis.
like that
You
when
look
you're
dead
looking at
south.
it. Jeez.
Now, we're not doing
got
that
no
right now.
idea
We're looking
of,
north, okay, from the south. We're looking dead north. This is over my head. The southern skies come out over my head. But I'm
You've
looking
got eyes
dead
on the
north.
top of your head, have you?
For 9 months of the year, there's a gap here. There's a gap between the 2 sky rotations. And for 9 months of the year, Orion's belt will pass through this gap. Anybody who has a little bit of skill in photography will notice the gap. Oops, make more of a gap here. The stars will form in this arc, but there'll be a straight line through here where Orion's belt will travel.
Be alright if we had a star
Orion's belt
trail
travels
or
through this
a
gap
time
for
lapse.
9 months of the year. 9 months of the year. Which means you're looking at the dark side of the spinning ball for 9 months of the year. But 3 months, it's in the light of the sun. You cannot see it. You'll be looking at the day side of the earth. So let's draw this another way. There's your spinning ball earth.
How can you...
There's the sticky thing they stick in the middle. Say north, south. And let's say the sun's way over here, but a long way away. That's the day side of the earth. There's the night side. Here's the equator. And where we see Orion's belt is at the celestial
It's
equator.
worked out that the day side is on the
Directly
light
above
side.
the
This thing's
equator.
on the light side.
So there's night time. So we're seeing Orion's belt for 9
nighttime,
months.
daytime.
And then it gets lost, and it's lost in the sun for 3 months. There's no way, in their spinning ball theory, you can have Orion's belt on the dark side for 9 months and then lose it on the sunny side, facing the sun for 3 months. I'm not going to go into the full details, I've got to move along. You just think about that.
Because
You look at their science.
Because you don't have full
It
details.
does not work. It
Yeah.
does not work.
No.
They have no explanation for
We'll
it.
just skip
It
that
can be
bit.
fully
Don't worry
explained
about
in
it.
the
It's all right.
flattest model
We
that I know,
don't
and I
have
have.
any details other than
Okay.
full details.
That gap there. That's one. Let's move along. Got some modern technology. I used to use a rag.
Modern
Even going across some
technology.
fluid to
It's
wash
a
the ball.
whiteboard rubber. What the hell?
Right. This is a
Those
seasonal change.
whiteboards come
Okay.
with one for free.
Oh, dear me.
This is to do with why in the southern hemisphere.
Be alright if you had a whiteboard marker that we could see.
Why in the southern hemisphere that we can see the sun.
Yeah. That'd be really
Let's say
modern technology.
There's a dividing line between day and night, okay? That half's day side. The day side,
Daytime,
We're looking for-
nighttime.
from a southerner's perspective, okay? And this is night.
Insert daytime, nighttime
sorry.
GIF.
No,
Now.
we're going to do that's
Clip.
night.
Yeah, you need to
We're talking
get
about
one, Terry.
stars.
You play.
I've
The
got
night
one.
half and the day half.
You should have played it.
And here we have east
No, you don't have
west.
to do it now.
North, south. Now, as a person in
mean,
the southern
it's here.
hemisphere, he's looking north at night. Oh, sorry. We're going back. We're talking about the sun.
Oh, it's
we're
not
talking
there.
about the sun, so it'll be day,
Oh, I went to the wrong place.
night. So in the morning, normally in the winter, these are classed as the gates. The sun appearing over the horizon in the morning. It just moves up in the winter. But at the solstice and after the solstice, we start getting more daylight, more daytime than nighttime, right? Which means moving this line down, exposing more
Nighttime.
of the cycle of the sun.
Nighttime.
So we end up getting the sun, seeing the sun more
Having a game of
south
nighttime, daytime. You want to play?
east in the summer. Because this line is moved down a bit.
Oh.
Right? And that midway line would actually move up a bit if it's in the winter.
I was only joking. You didn't have to do
It's
it.
less day, more night. Okay?
But I had to.
Why are we seeing the sun come up north,
Of course you did.
southeast, not east? Because this is the cycle of the sun. This is the cycle because it goes like this. There's the north, there's the Arctic circle, there's the southern Antarctic circle. They're mirrored. So when in the north they see the sun come around this way from their east, across their horizon during the day, we have it come out of here and go around here and go over our arc of horizon.
Hey?
So the more summer we get, the longer the days,
So what
we
happens
get to
at
see
the
more of
equator
the
then?
track, the cycle of the
Yeah.
sun.
You see two suns
Okay?
Yeah. Yeah. She's
on the equator.
But we can't see this right back here because that becomes night time. Because if we look at the daytime, and behind us will be night time. But when this is night time, behind us will be daytime. So we can't see them both at once. So it's coming out from the night into our arc of horizon. That's another thing, understanding man's arc of horizon. Every man has his arc of horizon. He is here below zenith, 90 degrees. All the celestial bodies come to him perpendicular to that arc.
Can I just change
Yeah,
the
you only see
words
so
that he
far.
uses for
Every man has their own view of the night sky or the sun or whatever. Every man's arc will have.
Can I just change the word of arc of horizon to field of view?
So you understand that? We're getting more sun coming around.
Is it better
we
than
can see
arc
it come more
horizon?
southeast in the morning
No, it's basically,
and then swing
Everyone
over
has
our
their
arc
own,
of horizon and go more.
Yeah, I know. He says.
it's basically almost like simulation theory, you know.
Hmm.
That everyone has their own
Okay?
personal
You'll see the same in the north in
sky,
your seasonal
effectively.
changes. Instead of seeing it come here in the winter, you'll see it coming further back in the summer. It's exposing more of your day cycle, the sun cycle.
So I know what every woman
They
has then.
possibly explain that on their globe model, but this is how it works in reality on the flat earth model. Okay? It's 2. Three. This is the best one. We have the globe model and the sticky thing. North, south. There's the equator. They tell you get a star rotation because the spinning ball is spinning east while the stars move west over us. And if you look to the north, you get a star rotation, and if you look to the south, you get a star rotation. This one's centered on Sigma Octantis, this one's centered on Polaris. But if you know anything, I'll just close the door, it's alright. If you know anything about star trail photography, you will have to fix your camera in this, on this meridian, north to south, on the flat earth model. Centre is north, right? South is all the way around here. Everybody is a meridian, north to south, no matter where he is, he's on one of these lines. So if you're in the southern hemisphere, out here, you'll fix it on sigma octantis and star trailless rotation. Now this rotation,
So if you wanted to ask where somebody was, they say, no, I'm south. Yeah, but which south? My south. Yeah, but which south's that?
if you take another camera and put it on an equatorial mount and fix it on one of the stars in here, what's it going to do? That star is going to drift this way, west. Guess what speed? 15 degrees per hour.
Thanks, Bob.
Per hour. You cannot explain that on a spinning ball. You've got a 15 degree rotation here because they tell you the ball's spinning, and then you've also got this 15 degrees drift. All fully explained on the flat earth model, but the globe cannot explain this. They stick to this one model or that
You got
model.
that ass backwards.
They don't talk about the two at the same time. Anybody can do this. This is a fixed rotation. It does not move left, right, east, west.
Okay.
It stays there, constantly circling sigma
Sit on the
octantis
equator and do it.
all night long.
One
But if
camera
you
north,
use
one
a
camera
tracker
south.
or an equatorial mount and track the star, it will drift west. Because all these stars are all slowly winding around the central northern hemisphere. That's a wheel within wheel, or wheels. Because this central rotation projects its image out this way, out south. So there's always an image out south coming from this central image. That's another one. I mean, there's plenty I could show you, but I'm just concentrating on the 4 or 5 or whatever it was. This is how it works. So, completely destroying the globe again. 2 separate 15 degree rotations. Absolute garbage if you think you live on a spinning ball.
Well, we don't think it.
I can never understand how that people.
Right.
Sorry, Terry, you go.
No, you go.
No, I was going to say, I just can't get how this idea is that we'll say it doesn't work on this globe model, when obviously clearly we can make it work on the globe model in theory, and then sort of just by saying it somehow that proves that it's not right. It's sort of like you can get 8-year-olds to show you how it works. It's not difficult.
And I thought he was going to tell us about something about night photography as well.
Well, he was, but then he talked about an equatorial mount would show that the thing going 15 degrees in the wrong direction or something rather. I'm thinking, that's not what happens.
I don't think he's ever used an equatorial mount. I don't think he's even seen an equatorial mount.
No.
He can say it, but he doesn't. Yeah, he doesn't know what it is.
Well, I only get that
Once,
feeling.
I must have confused one of these. Seeing the sun coming from the southeast. Solstice with day has become, well, that's the same one. More of the sun's journey. You see more of the sun's journey. We'll have to reduce one down. I'll have to just work on the 4 today. And that's the other one. Seeing the 2 rotations for one place on Earth. How can you look from, say, the southern hemisphere, 37 degrees south, and see 2 separate rotations? Does not make sense, but they've... They've just muddied the waters, smoke and mirrors, and the common human being just goes along with it and just think, that's normal.
Oh,
You can go on this story if you're in the northern hemisphere looking north and see one rotation, and then turn around and maybe look that way and see a southern rotation.
He's drawing a full rotation, but we don't see a full rotation unless you right down south. You'd have to be fair way close to the South Pole to see a full rotation, wouldn't you?
Well, yeah, because you can't see stars all night unless you happen to be in the polar night.
But you can't stand back here and see both separate rotations. If you live on one spinning ball, it would be the sky should be rolling basically like a rolling pin. There's no merging, there's no gap, there's no merging. Complete nonsense, but the common man just lives with it and takes his children to school and teaches them all this rubbish. Lies. What's wrong with the human mind? Why do they want to learn lies? Why do they want to let their children go to school and learn all this stuff? Do they care? I don't know. I'm baffled. So there you have it.
Oh, they don't want to
Yeah.
learn about stuff that you just made up on the spot.
Ryan?
Paul. That's why. How? You moron.
About 9 months of the year, it is seen on the dark side, if you go with the spinning ball theory, and 3 months on the sunny side, which we do not see, of course, because in the light of the sun, light of the sun. That's that one. Then we have the seeing more
From
of
where?
the sun's journey in the summer months. Coming from the southeast for southerners, or more northeast for northerners. There's two, there's one. What was the other one? The two separate 15 degrees per hour motions of the southern stars. Now you can't do this up north, you can only do it in the southern hemisphere stars. One, star trail circle, and the drifting of the stars west over the night. And this is because the southern stars revolve around the northern hemisphere.
He's making it up. He goes
Fair.
along.
Yeah, exactly.
Centre. Wheel within a wheel. Wheel within a wheel, or wheels. Check out all the
Your wheelie
my
wong
videos,
there, you
it's
know.
all in there. That's three. Star. And the fourth one, remember your arc of horizon too. Fourth one is
Get a
seeing
whiteboard marker that works.
two
The
separate,
bloody pen that works.
Yeah, that's what I said.
How'd
a
you
whiteboard
see it?
marker.
separate. Still running? Yeah.
Oh, I thought you
Seeing
said, I
two
thought you said
separate
white.
star
Checking
rotations.
the camera to say, are we still running?
Star rotations at the same time.
Hey, very, very expert.
Same time. With a gap between them.
No, I don't think he has, Judy.
Rotations. wear Orion's belt.
Why doesn't he get a cheap laptop and a webcam? It'd be a lot simpler. He wouldn't have to
Belt
cut his
passes
videos
through.
off then, will he?
Yeah. He's doing it on the cheap.
There it is, guys.
Yeah.
4, 2,
Or he
1.
could be not technically savvy, so...
There's many things I've discovered.
Maybe.
He
So,
definitely doesn't
if you
seem
want to support me in my
understand
work, please
edit.
let me know.
No, he doesn't understand editing, that's for sure.
Or you scientists and physicists on my channel, because I think half of them are, or they want to be scientists. Put my name down for a Nobel Prize, I wouldn't mind $1 million. Keep me out of a sticky bind at the moment. Would come in very handy. Okay?
Yeah, go on, admit it then. Go on. I dare you. I dare you.
Yeah.
That's all this video is about. And if you're very interested, go look at my other videos.
And get the same
I tell you what,
response.
maybe we should all nominate him for the Nobel Prize. See
You'll get
what
the
they
same
say.
response that Riley tried to do by writing that thesis.
And
Yeah.
subscribe. Cheers.
Thesis. That wasn't a
Wow.
thesis.
Okay, anyone understand a word you were saying?
No.
Okay.
Nope.
No.
Oh, we're all in the same boat then.
But it had nothing to do with his stated subject, though, did it?
No.
Well, he
Nothing
mentioned
about
he mentioned the
astrophotography.
words. He mentioned the words.
But then nothing. Yeah, astrophotography had nothing to do with astrophotography at all.
Well, no, he wasn't talking about astrophotography. He was just talking about what the stuff in what he thinks the lights in the sky do.
Yeah.
So obviously he hasn't looked at star trails because he's saying he's saying full star rotations. We don't see full star rotations at this latitude or at our latitudes.
Well, you could see full star rotations if there wasn't this inconvenient thing called daylight.
It does annoy me when when anybody and any flat earthers mentions about the education system, failing and not teaching the children the truth. I mean that really pisses
Yeah,
me
that
off.
really
That
irks
does.
me. That does.
Yeah.
They want
I mean,
they want you to be flat Earth to be taught, but then flat Earth comes under the umbrella of pseudoscience and conspiracies.
Yeah, well, as soon as you start saying things like it's proof, then that is pseudoscience because you're dismissing anything else.
Yeah.
Well, what would you teach anyway? Because every flat earther has a different notion of what the truth is anyway.
Well, yeah, exactly.
They don't actually agree on what is the truth.
No.
Yeah, exactly. They always argue amongst themselves sometimes.
Yeah.
There's ether, there's no ether, there's a dome, there's no dome. It's an infinite plane, it isn't an infinite plane. It goes on and on and on and on. None of them can agree.
There's
But,
lands,
I mean-
there's lands beyond the dome or the ice wall, and there's not.
Yeah. I mean, my daughter did her first paper of her GCSEs early this year, and she got straight A's, and it just kind of irks me. I can't really explain what I mean, but I think because if you have children yourself at a particular age, my son is yet a few years to start doing his GCSEs. But if anybody interrupted with that education thing, I'll tell you what, they're here from me. That's for sure.
Like, if they started teaching this in school, kids would be out there going, okay, we'll get a telescope, we'll get an equatorial mount. They'll get things where they can go and look for themselves. But what are they going to teach them in flat Earth class? Don't do any experiments. Don't go and don't do any research. Don't. Just listen to what I'm telling you, and this is what you have to learn.
Yeah, whatever you do, don't come up with any models, kids, because if you happen to come up with a model, then that could be falsified. So we don't want that.
Yeah,
exactly. It's cartoons. Don't read these books because they're all cartoons. Yeah, don't do that.
Yeah, and anything you can physically do and observe yourself are real.
Yeah, don't do that. Don't do that.
Trust your
So
senses,
don't drive cars
even though
'cause
we
you
know
can't
your
see them.
senses. Trust your senses, even though we know your senses can be fooled.
Yeah.
That's right. Yeah, that gets me, that one as well, about trust
Yeah.
senses.
The
They only want you to trust your senses when it suits them, you know.
Yeah.
Yeah.
So the first
Trust your
lesson will be
senses, even though our senses. Trust your senses, even though we know they're utter shite.
trust your senses. Can you feel the Earth move? No. Well, there you go, flat Earth.
Yeah, no, thank you very much. My daughter got straight A's in her last exams, so thank you very much. So I don't want you interfering with her education. Thank you very much. And she got straight A's in all her sciences. She loves science as well. She loves it.
Pardon the question, but what's a straight A? I thought A's had these sort of like angle things.
Oh.
Yeah, they're not straight. They're on an angle.
Yeah.
They're straight lines, aren't they? Well, what do you want?
How was that different from a curly A?
Yeah, A's.
And
Well, depending on the script you use, A's don't have any straight lines in them at all.
I thought a straight was a sequence, like King, Jack, Queen, not just A's.
Yeah.
That would be.
I mean, wouldn't that be A, B, C, D, E?
Yeah, that would be a straight.
Yeah.
And would that be the full house?
No, A would be the full house.
It's like, honestly, you guys are geeks. You really are. Do you realise that? You
What?
realise you're geeks, right? You did. And only geeks would argue about something like that. It's like, straight A's, you can't say that. That makes no sense.
I mean, I know I'm a geek because when I hear flat earthers say things like dielectric plane of inertia, I think, what? An insulating two-dimensional mathematical concept remaining at rest or constant velocity? What do you mean?
What?
Exactly, word salad.
Yeah, word salad.
Can you say that again in
God.
English?
Dielectric plane of inertia. I mean, this is one of their word salad things. Dielectric is an insulating material. A plane is a two-dimensional mathematical construct. Inertia, staying at rest or remaining at constant velocity. So when they say dielectric plane of inertia, what they're really saying is an insulating two-dimensional mathematical concept remaining at rest. What the hell does that mean? What the fuck? Pardon the language. Incoherent dielectric acceleration. What?
Yeah.
You're telling me that an out-of-phase insulating material is changing velocity? What does that mean?
Yeah, I tell you what, Paul. Watching that stream of tunes earlier,
Yeah.
I kept ending up getting word salad going around in my head.
Oh, yeah.
That isn't actually word salad, and it has to. And I shall say the word salad, but it should be sung to the tune of Old MacDonald's Farm.
Yeah. Yeah.
E-O-E-R, A over ducks. And I'm sure Paul got what that actually is. It's one I haven't forgotten.
I mean, like, Whitsett comes out and he spouts bullshit like, he says that the electrostatic force is 10 to the power of 36 times the strength of gravity. But doesn't that mean that gravity has to exist for that to be true?
I think he wants to say it's
Yeah.
10 to the 36 powers greater than the supposed force of gravity.
But he doesn't say that. He says that it's 10 to the power of
Yeah, I know he
36
does.
times stronger than gravity, which kind of indicates that, yeah, well, okay, you're admitting that gravity exists and the electrostatic force is a shitload stronger than that. But then you're trying to say that it's all electrostatic when it clearly isn't. Man.
Well, seeing as you had already watched partial, or most of,
Or
or all, if you sat through it all,
I might have fallen asleep in the early morning hours.
all. I couldn't sit through it all, Terry. I'd just put it on while I'm doing something else. Otherwise, it'd be a complete waste of time.
Yeah.
You know.
Oh, well, we'll play a few minutes to start, so we get a bit of a feel of how it starts,
Yeah.
and then if you remember which bits to jump through, I'll do a couple of jumps.
Doesn't really matter where you jump to, Terry. It's all pretty.
Okay, so I'll do
Also, yep.
I'll do a third jump. I'll do a third, then another third, and then that'll be enough time.
Yeah.
Okay. We'll get past the introduction there. We'll go to jump to there. So, who's this guy?
Brian
Brian
Myers.
Myers.
Bryant Myers. Yeah.
Has he been
He's-
around
he's-
before, or have we heard of him?
I don't know what he is or like what kind of a job he has, but he's obviously got some sort of background in physics because he
Yeah.
actually understands a little bit of physics. Which
He's
is
new.
Apparently
He's
he's got-
new. Sorry,
He's
go ahead.
new.
Em.
Mm.
Yeah, he's new to
Apparently
the.
he's got a bachelor's and master's degrees in physics.
okay. Cool.
Okay.
Yeah,
And works
he's,
in the field.
yeah, he's pretty new to the scene, Terry. He's not. He's been around I don't know, a couple of months or so. I
So he
suppose.
hasn't learnt all the word salad yet, or is he just? Or he's
No,
got his
he's
own-
still he's still learning who the characters are, and and flirf language and things like that. So, but
Oh,
yeah,
okay.
he definitely knows his stuff. That's for sure.
Hmm.
Still thinks she can convince Flurfus with
Oh.
logic and science and
Yeah, a bit like Professor Bell did when he first started, but he knows now that he's not going to do that, and
Yeah,
he's going to
exactly.
Yeah.
Oh, Blue's got to go
But-
to the doctor. Why is it every time we stream, Blue's either got to go to the doctor or the optometrist or?
because we make him
When you keep on playing shit like Lindsay, I mean, like, surely you can understand why he has to go to the doctor.
He books his doctors in. Oh yeah, it's going to be
Yeah.
Lindsay. Yeah, I've got to go to the doctors. Yeah.
Yeah.
I'll see you later, guys. I've got to go and feed the cat. I haven't got a cat. Okay, we're ready to go. I don't need permission, Matt. Oh, Matt's
you going to
muted.
sleep.
No, Matt's fallen asleep.
muted.
Pelding is asking, could you, Bryant, define what is meant by incoherent dielectric acceleration? Well, it's something that not even the flat earthers who believe it causes downward acceleration really have a good explanation for, but we've tried to kind of pull out a few of the things that they've said. So, all right, are you able to share? Is it
Hold on.
is it letting you?
Just a little.
It looks like it should for you. So,
Hold on a second here.
okay.
Apologies. I need to get a little more proficient here with Zoom.
So I'll explain while you do that. I'll try to explain a little bit. It's based on, so incoherent is like things have charge and they have neutral charge in general. But if you have something,
I've heard this other guy before, but I didn't think he was a flat earther. Because he was on
No, he's not.
debate. Okay. I thought this was a debate between a flat earther.
No, it's
No,
not a
no,
debate.
no.
It's an analysis of the debate between him and Whitsitt.
Ah! Yeah. Yeah, yeah. Okay.
thing that causes the charges to kind of separate. So imagine a water molecule where there's a hydrogen and two hydrogens and an oxygen, right? And maybe the electrons from the hydrogen are more towards the oxygen side. Well, that means that that one side of the hydrogen, or so the water molecule, is slightly positively charged and the other side is slightly negatively charged. Kind of what I get from their incoherent idea, but of course that is evenly distributed because all of the water has got random angles to all of the different bits of the water. So there isn't a net positive side to a bucket of water, and there isn't a net negative side to a bucket of water. It's all just randomly distributed amongst it, so the net charge is still 0. So, okay, we've got...
Okay, we're almost there.
he's...
I'm just trying
All
to
right.
share this portion of my screen, and it's not.
Yeah, it's kind of zoomed in a little bit.
Let's see here. Wait. Here we go. I'd like to do this feature where you can just
I've noticed this,
keep this
the
one
common
portion that
theme
way.
with Toon. Anytime people share,
on,
he's
Zoom.
got their window to
All right. Well, I'm
not the right
we're
size.
both working on the getting the.
We
this
didn't have much time to
Yeah.
put this up before.
Yeah, I was. If you weren't on I was on a different stream just before this, so I was a little bit with
I don't
Gary
know what
Wybenga.
I don't know
by
what
the way,
streaming
if you're
software
really
he
interested.
uses.
I was on Christopher Enoch's channel, and Gary Wybenga came in to share his
Yes,
his claims.
I think we got it here, MC.
Yes.
Can you see the? Okay, so we got the.
Yeah, it looks good.
Now I did get some like last words from Witsit before this is kind of his last comment, because I was trying to kind of get out of him. It's okay, where does this 9.8 all the base, just to try to make sense of it. So and like how can it be super strong and then be super weak? How can it sometimes be attractive and then sometimes be no charge or negative or positive charge, is charge and discharge, right? So there's like these 4 different explanations that he has. And so this is the last comment I got from it on YouTube. So he's saying there's a downward electric flow on the earth that sets the up and down. No one is claiming a giant force pulling things down to the earth. The downward bias sets the up and down. There is provably an electric flow down on the earth, and it's very weak. Okay, now was I mishearing him when he said it's 10 to the 36 times stronger than gravity?
He did say that. Well, all right. So he said that the electrostatics in general is 10 to the 36 times more powerful than gravity.
Right.
And now
So-
he's saying that maybe this isn't electrostatics. Maybe he's saying this is electric flow.
Electric flow. Well, the gravity is kind of weak. So if he's going to use electricity or electrostatics to create gravity, it's got to be kind of weak then, right? Because if you're going to, it's kind of weird that he said it's so much stronger than gravity, yet he's trying to use it to explain gravity. So it's like there's a little problem right off the bat with there. And so this is kind of the main thing. And I kept going back and forth with him with email debates, and he just can't. There's just nothing they can do to get 9.8 meters per second squared outputted from their model. I mean, they don't have a model. That's the problem, right?
Yeah.
And so all he had was these electric universe papers that you and I have kind of looked at, Morton Spears and others. And it's like, okay, they come up with a value for G, then you could say, okay, now we can calculate little g, but it assumes a spherical Earth.
Yeah.
So it doesn't help.
Yeah.
them.
So for people that don't know, Gleam and Atlas 6355 is mentioning this. Gleam, who is not a flat earther, he knows that the Earth is spherical, but he likes to LARP as a flat earther. He posted a whole bunch of electric universe papers on Witsit's video. Witsit sent them all to Bryant, but Witsit did not read them. Not only it's one thing to read it and not understand it. He didn't even read them. But most of them agree that mass attracts mass, and they were different proposals for how mass attracting mass might have an underlying electrical component to them. Their hypotheses is what they are essentially.
Yeah.
And none of them claimed that mass does not attract mass. They all affirm mass attracts mass. It was just about where it was derived from.
Yeah, and they all claim a spherical Earth too. None of those papers are going by the Earth being flat. And so now, just so that Witsit, because he loves, you can see from this thing here, he loves the claim that I'm straw manning him. So can you play those video clips, everybody, just so he can't say that we're straw manning him? Because I want him in his own words to lay out his model.
Yeah,
So that way
right.
we can go through it and not put words into his mouth, right? We're using to use
On
his
the
words
flat
and
Earth,
his
there's
model.
any response to them is a
All right,
straw
I
man,
will,
and they use that
we
all
need
the
to
time.
see. I don't know if we even need to see. But this
what's
is
that?
all right. If you play it, it might come through. Then you can control it. Oh, but no, it's come. Oh no, wait. We see it here. All right, hold on.
Okay.
I
So there's
could.
positive charge, potential charge. So
All right, did you hear that?
I heard it. Yeah.
Okay, well here we go.
So, what we actually see is that we have atmospheric electricity on the Earth. So we have an increase, equipotential increase. It goes up 100 volts per meter. Okay. So there's positive charge, potential charge increasing up from the surface, 100 volts per meter. Now, the only way that can be replicated or accomplished in any way, in any actual demonstration in the world, is you have to have two Gaussian surfaces. You have to have a surface above and a surface below to get that equipotential increase. It's the only way. There's no other way that can be demonstrated. So,
Okay, so that was number one. So we're going to play by his rules. Okay, so we're actually going to go by his explanation, and we're going to it's going to be killed dead, even in their model. So we're going to assume that what he's saying is true, and we're going to show, and then we'll kind of add more things to it after that. But so can you play the next part? So this is a setup. So he's basically setting up. Can you still see my screen?
Yeah, yours is on right now. Yep.
Okay, so he's basically setting up this 100 volt per meter equipotential sort of increase in voltage. Okay, and now the next little clip, he's going to talk about the downward bias, and this is where he mentions 9.8 meters per second. So if you could play that one now.
flow of electricity on the Earth. So that's what gives you the downward bias. So when something fluctuates between 9.8 meters squared and 9.73, well, okay, because electrostatics is super weak. So the change in electrostatics would never be drastic. It's an agreed upon average.
What? I thought electrostatics was 10 to 39 times stronger.
Not all things go down. Sometimes things go up. So we can actually manipulate that variable. We can prove it's there. All matter has it. It's tangible. We can actually manipulate it in an experiment and prove that it causes things to go up or down.
It's either one or the other. You kind of both.
For those wondering, I was doing a live commentary, and so you're seeing my live commentary get added in. All right, go ahead, Bryant.
Yes, I mean, I just like your version better anyway. So now he's saying, okay, so from this gradient, there's a downward bias, and I couldn't get out of him. It's like, are you talking about just a one-way vector with no magnitude? That doesn't. I mean, if you're dealing with a 100 volt per meter electric field, that provably has a magnitude. I mean, you're using these numbers, right? You can't just say that it's a downward bias only. It sets, but then what causes things to go? Where does the 9.8 meters per second come from? He just says it's an agreed upon average, and
it's measured. It's not an average.
It's measured. I know.
It's a measured average, not an agreed upon average.
So he just wants to kind of use that number and then plug it into all the equations, at least at sea level, that we have in engineering and everything. And somehow that totally is fine with his model. Now the last part is, this is where the black swan comes in, the next clip you're going to play. Because now he's going to admit that, I pinned him down during the debate. I said, okay, what's your F? Because we, with our model, I don't want to give it all away here yet, but with our model, we actually have an equation, and we can predict G at any altitude. We use the Cavendish to get the value for big G, right? And then we can use that, put that into Newton's laws, and then we can calculate little G at any altitude, escape velocity and all this other thing. So, but even at sea level, we can at least have a derivation of G from our model. And he doesn't have that. So I pinned him down. I'm like, okay, what's your force equation? If it's not gravity, it's got to be Coulomb's law, right? Because this is, you're talking about an electrostatic gradient of 100 volts per meter. That is electrostatics. Electrostatics is governed by Coulomb's law. I mean, there's no Walter Lewin, the guy that you love to quote so much. He's got a lecture on electrostatics, and guess which equation Walter Lewin derives for us? Coulomb's law.
Coulomb's law.
Thanks for everybody's patience. I just wanted to do this so that everybody can hear that it's coming from his words, and I'm not straw manning him. So can you play the last little clip, and then we'll get in.
Yep, here it comes.
Force, that says F equals. So yeah, force equals mass times acceleration.
Okay, but again,
acceleration
what's the acceleration? Where are you getting that from electrostatics?
That's what everything is. It's
But
literally all
you
electricity.
got to use Coulomb's law to derive that. Then, if you're using electrostatics,
We could use Coulomb's law, but it doesn't matter. The thing here is, my God,
that's what Walter Lewin, when he did his presentation on electrostatics, he derived
It's
Coulomb's
gold.
law. That's the
Gold,
equation he
Coulomb's
used for
law.
electrostatics.
I know. Yeah, it's
Well,
almost exactly the same as
well,
the
then do
gravitational law,
it's
but
not.
it's
Oh my
just
gosh.
charge is different.
that last part was priceless. He's saying because it looks like Newton's law of gravity with K Q1 Q2 over R squared. He says it's the same, but yet he says it's 10 to the 36 times stronger, and it is. So you see the contradiction here. He's saying it's the same as gravity, but it really is 10 to the 36 times stronger. But now in this situation, somehow it's super weak. Somehow Coulomb's law has morphed into something that applies to atmospheric electricity that's totally not what we know Coulomb's law to be. So I just kind of want to come right in and just with the black swan, let's not waste any time here. So with Whitsitt basically, acknowledging that Coulomb's law, it's what we need for electrostatics. I mean, there's just no debate about that, right? So, well, actually, let me do these two figures here first, because it takes it through it more pictorially. So the problem here is that, the problem is that the gravity is when the acceleration due to gravity, the inertial mass cancels the gravitational mass. Actually, let me just show this right here real quick. So over here, we have, when we set F equals to ma equals to Newton's laws, we can kind of regroup it to ma, and here's our acceleration. And because inertial mass is equal to gravitational mass, and this is what led Einstein to general relativity, right? He realized the equivalence of these two masses and that they canceled out. And this gave rise to the curvature of space-time that he developed from this insight. And so because of this, the gravitational acceleration is constant at sea level because the masses cancel. Okay, now, here's the black swan. Now with electrostatics, we do the same thing, okay? We set F equals to ma equals to QE. And for those that maybe don't know, QE, the electric force, is basically just Q or KQ over R squared. So it's basically the force per unit charge, just so simply.
K is a constant. Q is a charge.
K is a constant. Q is a charge. And the beauty of doing it in the electric field format is that you can just, it's like the sound of one hand clapping. You only need one charge. And from that comes the field, okay? So you don't need an action at a distance. The field formulation is also really nice in gravity, even before Einstein.
Yeah. And so to give a little background to people, Coulomb's law is about 2 points. 2-point charges, and then there's a field version of that. You can derive the field version of that. That's what we're looking at here. This Q times E.
And you're just dividing by Q. So essentially, it's Coulomb's law divided by Q. So just for clarity, this is Coulomb's law here. And because he's listing it as 100 volts per meter, that is an electric field. So it just kind of flows into this equation better than the expanded form of Coulomb's law, the 2 points. So when we do this, we set, then we solve for A. So we got F equals ma equals QE. So A equals Q over M times E. I hope everybody's following. And now, I
have to give some commentary on this. If you're not following, that this is saying that that the acceleration is relative to the charge and inversely proportional to the mass.
Yep.
Okay.
exactly.
The
So
charge
we have
of the
our
object.
100. So even though the electric field is constant at 100 volts per meter, and oh, by the way, when you do all the units, it does come out to meters per second squared. When you use the K, it comes from the K constant.
Yeah.
You know, a lot of the units are, so you do get meters per second squared out of this because this is 100 volts per meter times Coulomb charge and divided by mass. So here's the thing, look over here, gravity constant because inertial mass cancels gravitational mass. Over here, there's no equivalent to an inertial charge canceling a gravitational charge. So you see the problem? So if we double the charge, we double the acceleration. So if
you change the polarity of the charge, you change the direction of the acceleration.
Yeah, so I'll get to those pictures in a second.
Okay.
So now, but it's also mass doesn't go away either. So now you have also to divide by mass. So the only way you can get 9.8 meters per second squared is to fiddle with a charge and a mass that makes it work. But then it's going to be, it's not going to be the same for, so everything is going to have to be.
If the charge is the same for everything, then it's going to be based on the mass.
Yeah.
Which you'd have to have a very specific mass.
Yeah, a very specific mass. And so, but again, the point is they're not constants. Like you said, acceleration varies directly with the charge. So you literally double the charge, you double the acceleration. I mean, you double the mass, you half the acceleration. It's just we're over here, we have this beautiful, smooth, constant acceleration across the surface of the Earth, 9.77 to 9.83. Over here, you just have chaos. If you use this equation, and just to kind of drive this home here, I drew this little chart. So if you had a positive charge, okay, things will go down. But again, if you double the charge, they're going to go down twice as fast. Again, using their model. And then you got mass in here too, so you got to draw your free body diagram, right? And you got to check. Okay, so we got the force due to electrostatics, and we got the gravitational. And this is what I can't get from them. They seem to believe that mass exists. Like I even asked Witsit, that's like, okay, Witsit, when you stand on a scale, that is mass, right? What are we? So you're not denying mass, but then if you don't deny mass, then it's got to somehow come into here. If that's where they're so confused, right? Because those electric universe papers were trying to equate mass or somehow mass attracting mass to charges within the masses, creating this force of gravity, right? So it's just so confused. But even if we take gravity out of, okay, I did this simpler version here. Let's just assume there's no gravity. Just turn gravity off. You're still going to have those same problems of doubling the charge.
That's their claim, of course.
Yeah. Okay. So again, but then when you step on a scale, again, I don't know what that means. I even asked Switz. It's like, okay, if there's no gravity, and I stand on my scale, you're agreeing somehow that there is mass or density, right? They say density and buoyancy.
Yeah.
But how does that all fit in with this? But even if we just turn gravity,
they try to not say mass for some reason. That's kind of the trend. They say density instead of mass, but density is just mass proportional to volume. It's still mass,
right? And Flatswite in that debate with FTF, he didn't seem to know what density was. They really don't seem to know what density even means. And so, but here's the thing: if we have a negative charge, now things will start to levitate. They'll go the other direction.
And it would not take a whole lot either. If there's no downward acceleration due to gravity, if it's at zero charge, right? If it's at net zero charge, it will neither go up nor down. It would just hover. And a small applied negative charge would cause it to go up right away. You don't need large amounts of negative charge. Small amounts of negative charge would make it happen because there's no additional downward acceleration, according to them.
So, right. So, and again, I kind of put this is both formulations of Coulomb's law here. So you got, this is electric. So you can see. You got these so you got these three possibilities. And the thing with gravity is it's always down. In fact, just kind of for fun here, these are just kind of evidence-based observations of gravity. So it's based on mass attracting mass. It's always attractive. There's no polarity, right? There's no. I know some people try to claim there's anti-gravity, like Witsit and Dearth. With their little balloon, they like trying to show that this is It's not anti-gravity, guys. It's an electrostatic force you're playing with. It cannot. Well, we'll get to the cannot be shielded here in a minute. But it's a slow 1/r² drop off, which is spherical symmetry, by the way. Whenever you have a 1/r² law, that is coming from spherical symmetry. This is why, again, they're never going to get 9.8 meters per second to work because it comes from a spherical symmetry. And like I just said, it's the gravitational acceleration is constant at sea level. Oh, and this is something that kind of dawned on me, MC. you know how they have all those memes about Australia being upside down, and they just keep going on and on about that. Well, if their electric field sets a downward bias, I mean, it's like, that's your version of up or down. I mean, you're calling it something different, but it's the same principle. It's like, why is it so hard to understand? But it has to do too with our vestibular system registers only acceleration, right? We can't really feel it. We can't sense a constant velocity, and actually no meters can sense it either. So
it goes back to relativity. Constant velocity cannot independently be measured.
Yeah, can't be independently measured. There's no constant velocity meter. Even your car is using like the rim, whatever, your rim speed on your tires or something.
The tire touches the road. That's how it gets that.
Yeah, it's not measuring the constant velocity. But anyway, so the up and down, it just comes from this gravity, this force. And it's like kind of silly. It's like, flat Earth, and you have this same downward bias. It's like, I guess that's setting of course they claim that it's just based on the fact that the Earth is flat, and somehow that just makes, but you're still going to have something that's going to tell your brain up and down. And again, it's very uniform. So to me, and this is playing by their rules, MC. We're given Whitsitt his two Gaussian surfaces. He can have them. We're not going to even talk about how the electric field drops with altitude.
I want a disclaimer on that. There is no need for two Gaussian surfaces.
No, there's
but
not.
Let's accept his hypothesis that there is two Gaussian surfaces. It doesn't change anything.
It doesn't change. So we're playing in their world right now, and this still kills it dead. This is why to me it's a black swan, because we're actually playing by their rules. We're living in their world using what Whitsitt just said, and he can't claim a straw man because we just heard him say it. So
he said Coulomb's law, yeah.
And he said Coulomb's law. I mean, he has to. If he's going to use 100 volts per meter, I mean, honestly, they're better off just saying heavenly energy, because
it leaves it vague.
It leaves it vague, right?
Their best hope is to never say anything testable.
I probably shouldn't have even said that. Now I probably
you gave it away. They're going to start saying they're going to give up on
the ether. The next thing that's going to come along is going to be the ether and heavenly energies that we won't be able to do anything.
I mean, his Whitsitt's Papa Flurf number 2 is Bob Nodell, and he says he having heavenly energies. So whatever.
Jump.
Be shielded.
Yeah,
absolutely
because gravity
untrue.
Gravity cannot be shielded. So that's a fact. I mean, gravity is charge independent. I mean, it's actually the only way you can shield gravity would be a huge, massive shell of mass. And then you could maybe shield the gravity of a mass inside of that big, huge shell of mass. But here on Earth, we don't have anything like that to shield gravity. So gravity goes through everything. Gravity waves from LIGO went through the entire Earth all the way through. It doesn't get shielded. So this is something we know empirically. We can measure and we can see that nothing shields gravity. So this, again, is another way that it just kills it. I mean, electric fields can be shielded. And it actually comes from kind of a cool bit of science here. We need to use Coulomb's law, because this version of Coulomb's law is for like a vacuum, or with the dielectric constant being 1, right? But in reality, the atmosphere is pretty close to 1. Air, you can see. So we can pretty much safely use that equation in the air. But in different materials that have different dielectric constants, the electric field gets shielded. So an dielectric constant of 50 would be 50 times shielding, right? Which is the human body, by the way, it shields electric fields about 50-fold. And it's because water has such a high dielectric constant.
So for reference, the D in incoherent dielectric acceleration, they say, and you're using the word dielectric as it shields electrical charges. And inside a capacitor, the generalized capacitor is 2 plates, and between those 2 plates is a dielectric material, or any material that has a certain dielectric property. And a vacuum has a dielectric constant of 1, and they don't use that in capacitors generally, because it's not a very easy thing to make. So they usually put something between it. Sometimes it's an oil, some of the old ones, an oil-soaked piece of paper.
Yeah. And again, the better the dielectric, the better it can keep the charges separated, because you do want you don't want a leaky capacitor where the charges start to go from one side to the other. The whole point is to store energy across this gap. And so, yeah, I didn't think about that. Incoherent dielectric, just the word dielectric, that's a big part of, that's a big flaw in their
They're
model.
just throwing that word in because it sounds fancy. They're not using it in the way that dielectric actually is being used in actual work.
Yeah, this is the version of Coulomb's law in materials. So you can see this little E right here. So we have to actually, we're just taking this equation now, we're dividing by the dielectric. So again, you can see the force with water, it would be diminished by 80-fold. And I guess human body is about a dielectric of 50, right? So electric fields, so if somehow this dielectric acceleration was based on electrostatics, then the outside of our body would be getting more forces than the inside of our body, because it's getting shielded, and we have all this crazy things going on, right? With
we'll do another jump. Do they get onto any other subjects?
No, it's all pretty much about this notion of electrostatic gravity. But, obviously the flat earthers haven't really thought about this very much because, as Brian's pointing out, it's just not consistent with anything. That, the flat earthers love using this word dielectric, but they don't really understand what a dielectric means or what a dielectric actually is. It's just a buzzword for them that makes them sound smart, but they use it in such a incorrect context that it makes them actually sound stupid.
Yeah, they basically just pick up these buzzwords and run with them.
Yeah.
Yeah, they get the word, they find out what its meaning is, but then the usage of it that's where they lose.
Well, half the time they don't even find out what its meaning is. I mean, if you asked any flat earther what the word dielectric means, I doubt whether many of them could actually tell you what a dielectric actually is and what it does.
Mm. And dielectric is what the example of that oil-soaked paper in between a capacitor. Is that what?
Yeah. Well, a dielectric is any insulating material, basically. And what happens is when you subject a dielectric to an electric field, internally in the dielectric material, it sets up an electric field which opposes the external electric field. So you get a net cancelling sort of the electric field inside the dielectric material to a certain extent. It depends on the dielectric properties of the insulator itself as to the extent of that cancellation. Something like air is not a very good dielectric at all, and it doesn't cancel the electric field very much at all. And so inside a capacitor that's just got an air gap between it, you won't be able to store very much electric charge on the plates because the build-up of charge on the plates prevents any further charge from sort of gathering there. But if you put a dielectric material between the plates, then it cancels that electric field out between the plates, and you can actually end up storing more charge on the plates as a result of that. In fact, if you use a metal, a metal has a dielectric constant of around about infinity. And so, because it's conducting, and so it cancels out the electric field internally completely, and so you get no electric field on the inside of a perfect conductor like a metal. Anyway.
What you just described as a capacitor, right?
Yeah.
That's what a capacitor does. Yeah.
I'll remember that one next time I hear that word.
Yeah.
Oh, unmute.
But we know it's not a constant, and none of the flat earthers claim to be on an infinite plane, do they? Or is there?
There is the Infinite Plane Society.
Oh yeah.
Oh,
IPS.
That's a new one.
Yeah, there are those.
Well,
but to my knowledge, none of the infinite planers actually claim that gravity. They don't attempt to provide that as the explanation for gravity. They still go with all of the other nonsense about gravity. The infinite planers are the ones that could potentially offer that, but they still don't.
They actually could. They
Yeah.
don't. They're in the best position to offer a 9.8. Now it wouldn't drop off, but at least they can stay at the surface as 9.8 meters per
Well,
second.
and it wouldn't vary by location or latitude or elevation, but
No,
but at
right,
least,
exactly.
I mean, it gives them step one.
It gives them step one. They can get a constant,
1,000 steps.
which is a lot closer than where the current flat Earth models are at. So basically, what I was getting at here is because they have no math and no model, they resort to these little science experiments, or they just look at observations from nature, like spider ballooning. Bob loves that one, right? The bees attracting pollen, and they really think, MC, that it's levitating up to the bee. They just seem to think that because there's only one force, right? It's got to be levitation because everything is electrostatics. And I just wanted to show a little clip here from Dirth, not with the sound or audio, but I just kind of want to explain what he's trying to do here. So what Dirth is doing in this little experiment is he's got this helium balloons, right? And this little button on the bottom. And they're adding a positive or a negative, doesn't matter, charge to this button. And it's pulling it down. So they think because they can manipulate, this is why they think their experiment proves that their model is right. Because they think they're manipulating the independent variable to cause the dependent variable, right? And they're able to manipulate this electric charge to make it go down. And somehow this is a proof that things go down based on their model. I kid you not.
They didn't control for the existing downward acceleration.
No, right. They didn't draw a free body diagram and see all the forces. There's a buoyant force going up. There's a button, some mass going down. But yes, when you add charge, you create an induced. It's a London dispersion force, right? You're inducing dipoles in the floor that's then attracting. It's a very weak. But when you got a Van de Graaff generator adding 40,000 volts or whatever it is, that's a very strong. It can create a strong
40,000 volts or whatever they were needing to apply for this to work is a ridiculously large voltage, which doesn't work with their model, because if it's according to their model, a very small voltage would cause a large amount of acceleration.
They could have saved some money. The same principle was when you rub. I got a little wool thing here. I mean, if I rub the balloon with the wool, I can stick it to the wall, right? I mean, it's not hard. Anybody can do this with because you're just transferring charge to the balloon. So this is all they're doing is they're adding charge to that button, and the button's inducing a dipole and the going down. Well, guess what? If Dirth would have taken that button to the wall, it would have gone sideways. If he would have taken it to the ceiling, it would have gone up. It's nothing to do. It's just the proximity of the button to the floor that's inducing the dipole in the floor, right? I mean, this is. I don't understand. They think this is such great proof. And one more. This is. Dirth loves this one too. This aeroelectrodynamic thrust type of thing. So now what he says is now we're going to go in the other direction. Okay. So the first experiment was Dirth saying, look, we can prove that electromagnetic force makes things go down, right? Now I want to show you that we can also manipulate to make things levitate and go up. And it's not even electrostatics really, because it's doing. It's ionic wind, right? You're actually creating a corona discharge from the needles, and the air is getting pushed along with the electrons, and it pushes it up like a thrust.
The Dyson fan that's just a circle and has no blades in it.
Yeah.
That's what this is. That's what.
Oh, okay. I didn't realize that. But now then he's got the MIT one too, where MIT's got a really, and it's a cool technology where they can use ionic wind to create when they did their experiment, the plane didn't go very far, and they had to use 40,000 volts, right, to get it just because again, it's corona discharge. You're going from a thin electrode to a thicker one, and so the ions will, because of the high curvature, the ions shoot off the thin electrode, and it'll attract to the thicker one, and that creates a flow, just like an airflow across a wing, right? But now you're creating airflow in a different way. You're creating it actually from the needles, and you're kind of forcing. So the lift that's created in these planes that MIT developed, it's similar to the lift in an airplane. It's just the airflow is coming from the ionic wind, from the corona discharge of the ions.
Oh, Ben D said that they don't work in a vacuum. That's a great thing.
Oh, right, exactly, yeah.
And that's
and
using
they won't work at high altitudes. They don't work at high altitudes either. because you need a certain density of air for it to flow enough air, for enough air to flow over it.
So you could put it in a chamber and evacuate half the air and half the pressure. It would just start to affect it.
But when they say that, when you hear these flat earthers say we can prove our model, this is their proofs that they're talking about.
Yeah.
And it's like, and I went through, if anybody wants to watch my last video, I did a whole video on flat earth science, quote unquote science. And I went through a lot of these things, and absolutely none of them prove their model at all. They just prove that our current science works.
Yeah.
And we actually understand all the forces that go on here. And flat earthers only seem to think there's one force acting on a body at a time. They can't seem to draw a free body diagram to save their life.
And for reference, a free body diagram is just where you draw all of the forces and the directions that they're applying to an object. So the downward acceleration, gravity in our case, in their case, it's whatever. They don't quite have it defined well. But it's gravity, it's buoyancy, which works in the opposite direction. It's wind resistance if it's moving. It's electrical charges, just like that, right? Like they say, electrical charges is one of them. If they're not at the, but you don't need to include them normally unless you need lots of precision if they're small. So you wouldn't normally include electrical charge because it's going to be pretty deep in and probably much less than most measurements margin of error could even touch.
The thing with electrostatics is usually most electrostatics are on insulators, right? Because conductors, the charge is all kind of spread out.
Yes.
So insulators are better to hold electrostatics. So really, electrostatics in our daily lives is like when you rub your feet on carpet or your dryer or your little balloon thing I just did. Of course, lightning is an example. But most things around us, I mean, I've got this little electrostatics meter. You can measure. Most things are electrically neutral.
They don't have anything. Yeah.
Where is, like, if it is a negative charge and that would mean everything has to be, I didn't mention this. That would mean everything has to be positively charged. But then if everything's positively charged, attracted to the negative Earth, that means those positive charges repel. So we should all be repelling each other. And it's like just so many contradictions in their model, right?
They don't think to step two. They're like, step one. And then that's it.
This is not one or two. MC, this is not one or two problems we're going over here. This is like a baker's dozen at least. I mean, we've gone through.
It goes on and on and on. It's the same problem. Many things on flat Earth that they offer one explanation, and then that explanation contradicts 10 other things, right? And I call them off diagonal, right? So they make a claim. Here's a problem, here's the answer. Here's another problem, here's another answer. And that makes this diagonal. Problem, answer, right? But every answer contradicts a handful of other answers. Right? And so they have these off diagonal conflicts that happen and they just ignore them. They can't think about them.
Yeah. No, and maybe that's a better way of saying kettle logic, so we don't get more fallacy things going. But it is kettle logic. I mean, in the way that fallacy is defined. But it's just so they resort to these experiments, and I mean, I don't know, how are people just watching this and saying, "Oh, wow, that really does prove it." I mean, I don't. It just
because they're not that bright either, right? And this is the thing, Austin. You're not that smart. And the people that you fooled are less smart than you. That's how it works when you're fooling people, at least in that particular subject. Now, let me show. I have queued up Austin's boasting.
Okay.
Right?
Okay.
And I'll read them. I'm not sharing it to you. He said, no, keep sharing your stuff. I'll just read it to you.
Okay.
He said right here, my IQ literally towers yours and you constantly call me stupid.
You always
you people are stupid, and I'm not partaking in circular stupidity. If any of you actually believe the claim your intellect towers mine, then STFU, and jump on my live and debate it. We can do it right now. I'm clearly smarter than you. I have over 150 IQ. What about you? Believe it or not,
Oh,
pal, the
really?
fact you don't like I'm smarter than
Oh
you
dear.
doesn't make you smarter. You know that, right? So maybe you should leave attacking my intellect out of this, eh? And then finally, I take cues from no one. I bet my IQ is minimal of 50 points higher than yours. So if I'm dumb, what's that say about you?
Oh,
Well, thank you
wow.
very much, Austin. You should then easily be able to provide
Yeah.
the analysis that for these things that you say.
Yeah.
Go ahead.
And
Let's see
something,
it.
some actual real numbers, because 9.8 meters per second squared is a real number. And when you do these experiments, they prove absolutely nothing. You're not, how does this prove?
We'll
They're
do
so
one more,
confident
Joe.
too that these things prove their model. I mean, and I just watch this. It's like, really? And I don't measure the angle of deflection, and you can calculate what that force would be needed to deflect that plumb bob and set that force equal to Newton's force and solve for G that way. So the reason you're getting G in every single one of these cases is because G is the proportionality constant between the force of gravity and mass m1, m2 over r squared. So because it is mass attracting mass, you get the same proportionality constant whenever you do a very careful experiment. And again, there's more than just the Cavendish, there's different ways of doing it. But you're basically setting a known force a known force law that we can know and measure equal to the gravitational mass equals mass. Because Isaac Newton didn't know what big G was. So he had to set the mass of the earth times G equal to force M over R, he had to work with ratios. So, because he didn't have the G, right? But he could still, even with the ratios, he could still make a lot of accurate predictions with the solar system. So it's really cool that, that when Cavendish in late 1798 or whatever came and he got within 1% with his, even though we've come a long way, it's still amazing that he got better precision than I can get when I do it myself, because he put a lot of care into measuring.
Well, yeah, and when you have larger test masses, then you can have more precision too. So let me show you this. You'll have to watch on. Don't change your sharing. You'll have to watch on the live stream if you want to see it. But BM Furball set up. This is for you, Weiskopf. Set up in his
My
apartment
name's
in
there
Korea.
somewhere.
Set
If you
up
look carefully.
torsion bar, and you can see there going across the screen horizontally. Though that's the
I know it's
bar.
there
Those are
somewhere.
the masses on the torsion bar, and that's being suspended from the ceiling, and they are right now at rest. And there's
you on there, are you?
Yeah, my name's on there somewhere.
He put a mark on the
Yeah, I helped
bottom of it,
Furball
and
set
that's
this
where
up,
the
build
this
it,
laser is. So
all
there's a mirror that's on the torsion wire with the laser pointing at it, so that you can you can see small movements of the mirror.
It's a mirror.
Yeah, bring large movements in the reflected position of the laser. All right, so here it is. So here is, all right, so you can see the light there on the right of that black line that he added. And what he's doing now is he's moving from the other room. He has it's controlled remotely. He's moving the masses into place, the test masses into place. You can see it's a 40-pound dumbbell, and each side is about 20 pounds actually, because it's cut in half, and then he removed the handle. So this is moving it close, and then what happens is it starts to oscillate, and over time, I'll play it here. You can see I'm going to speed it up, and so over time you can see there it's moving to the left. You see that light moving to the left? That's the mirror moving, and the oscillation in this is it's not damped. Right, it's allowed to go until it just comes to rest, and it takes a long time for it to come to rest.
You gotta wait. From mine, I got a kind of a pre-made one, and I gotta wait a couple hours before it comes to rest. But it's got a. But you do measure the period, because remember, periods are not. I mean, even with the pendulum, right? Even if the pendulum slows down, the period stays the same, based on the whole setup. So you're just measuring and you do need to measure that period, typically with the typical Cavendish type of a calculation, and then when it comes to rest, you can measure the displacement, and then with the period and the displacement, you can calculate K, and then you can set the gravitational equations equal to the torques of the torsion balance, the restoring force, and you solve,
There it
you
is,
solve for
moving.
G.
Yeah.
I did,
Now,
did a
now
little calculation.
in this particular one, he was not seeking to measure the specific gravitational constant. He was just
okay.
testing yes, no, does mass attract mass? So then after this comes to rest after a couple days, is the light, the laser in a different spot? And then he moves it out of the way again and waits a couple days, and is the laser back to where it started?
Yeah.
That's what he was testing. So
Nice. No, there's some good videos. Actually, the video, is that the one of that physics teacher online? 'Cause I can't see your screen.
yeah.
That's a really good demonstration. That I think you shared that one. That physics teacher that did that experiment in his classroom, and he wasn't trying to calculate G either. He just was showing.
Does
like really big with big lead. It was very visual. I'm like, wow. You could really see when you sped it up 30 times.
Yeah.
That you could see the mass moving back when you. And I think you put a comment on his video. That's why I know. Oh, there's MC Toon commenting on your video there. Beautiful demonstration. Just a visual, just a very visual without getting into the math. You can see mass attracting mass very visually. And by the way, in the comments, people were trying to debunk, I think probably, I don't know if they were flat earthers, but trying to debunk the whole setup. And he gave very meticulous replies to those attempted debunks, that he electrically grounded it, that he talked about all the different things that he did to take into care all those, like you say, the confounding variables.
Yep.
But that's a good video to share because it's just.
So that's gravitational constant with the Cavendish. I don't know what else they talk about.
That's probably enough, Terry.
Yeah. It doesn't look like they're doing anything else after that.
It's pretty heavy, intense going, isn't it? Most of it.
It's a pretty comprehensive destruction of what Whitsitt was claiming.
Oh yeah, for sure.
So, but then again, I mean, that's what flat earthers' modus operandi is, really, isn't it? Just claim something without actually knowing what you claim actually means in terms of real science.
Like for an example, today I was over on Geos, and we're talking about something, and I kept on. I tried to butt in when I could, but it was hard. So I posted a few bits and pieces in the side chat, and the Globy type people are in the voice chat were commenting that that's what we're trying to say. This is what we're trying to say, and none of the flat earthers were trying to, dispute or whatever. They just weren't listening. All right. Oh, we're coming up to. Geez, we've been here 2 hours already. Where's time go?
That's funny you should
must
say that. That's what my quiz is on.
Time.
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 Have we got time?
Yeah. Well, it depends.
Got time for time.
How much time do we need?
Time.
For time.
How much time have you got?
I don't know.
Your show, mate.
Oh, I'd say you got a good few years yet, Terry.
Oh, okay.
A few years in you. You're not going to die yet, don't worry. Oh, these are not full of trick questions again, are they, Timber?
Timber's twisted test of terror.
I send that when you're drunk.
Yeah, we're going to have to give it a name, like the quirky quiz, the confusing quiz.
No, just gave it one. The Timber's twisted test of terror.
You can't even say that yourself, let alone anybody else saying it. Would you expect anybody else to say that?
We're trying
to remember what I said.
Yeah, I know.
I was trying to remember what I said the first time.
I was trying to simplify it.
Mortal terror.
How about Timbo's torture test?
That's even worse. Well, shut up, you lot. You can't say any of that when you're drunk. Just keep it simple. Timbo's questions or Timbo's test. And a whole lot of bloody word twisters in there. Tongue twisters, I should say.
I was actually going to do up an intro. I might do that next time. It's okay. Okay.
Timbo's tedious, tiresome torture test.
Yeah, something like that.
Yeah, Judy answered the question.
Okay, what year is this? It is. Okay, so I thought I'd did a bit of a theme, and I thought I wouldn't be as cryptic as I was last week.
I reckon it's
So,
still cryptic.
hopefully-
I reckon there's a trick to this question.
Yeah, probably.
Yeah, no. Okay. So I thought, okay, let's go back to some clues. So what year am I looking for? If it's nice enough to give me the next question, let's go back one. Okay. In this year, Walt Disney records his final filmed appearance prior to his death, detailing his plans for the let's get those things out of the way. Epcot Center and the Utopian Plant City to be built in Florida. Okay. So let me just get up some chat. So anyone wants to put in the chat? No, Alan?
So we're looking for a year, are we?
A year. No, I think cryptic, it's just a year. Okay, next clue. Coming down. The British Prime Minister Harold Wilson and Rhodesian Prime Minister Ian Smith negotiated aboard the HMS Tiger in the Mediterranean on this year. Oh no, truth nerds, that's a total. Your total guess is totally wrong. Sorry. Yes, Paul has got it all right. Correct.
I was 3 years old.
Yes, I wasn't that old. The next clue for the rest of it. The National Football League in the United States awarded 16th franchise to the city of New Orleans. The team will be named the New Orleans Saints. Put that in there for the Americans.
I think it's that.
No,
I think. Give or take a year.
Yeah. Give you take a year. No, don't take any year or give a year. That's correct.
Oh, really? Oh, nice.
Yes.
Nice.
Okay, next. I'm going to write answers out in the peanut vote gallery yet. Surveyor 1 lands on ocean. We had that Procilium, the biggest ocean on the moon, becoming the first spaceship to soft land on another world. A little bit more closer to one day, Terry, than that one.
Terry's letting everyone know he's wrong.
Okay. The 38th Academy Award ceremony is held in Santa Monica, California. And The Sound of Music wins Best Picture. Still haven't got any correct answers out in the peanut gallery. Just getting close, but not quite there.
You said Paul said 3 years something, and I thought, well, okay, how's Paul to me? I'm guessing.
Yeah, Alan, you're close. You're only a few years off.
So I must be close.
Okay, last clue. Let's see who can get it with this one. For the Australian dollar was introduced to the rate of $2 per pound and 10 shillings per dollar. What year was that? Yes.
But you're only 3 years old, Paul.
Yeah, I was 3 years old in this year, but have a look at your answer, Terry. Right?
Yeah, that's 3 year old. I was 3 year old.
What, in 1063?
No, the second you didn't see the second answer.
Yeah, no, he didn't. He put 1963 as he said.
Okay.
Okay.
Well, say because 1063, that's more than 1,000 years ago, Terry.
Okay, I'll try that one.
So what year? No, it's too many. Go down.
Oh, jeez.
1966. For anyone.
I'll go one more year.
Yeah, I think Croppy Old Gunt's got the answer out there.
Oh, did he?
He did, yes. That's it.
Yeah.
Yes.
Okay.
1966. Year I was born. That's why I picked it.
Okay.
Oh, blimey, you lot are all
Okay.
older than me. Wow.
1966.
Yeah, I would have
the FA
been. I
World
would have
Cup
been turning
begins in
6 that
England.
year. No, I turned 5.
Okay, if you didn't get it in the last clue, you have problems.
Yeah, well, because it actually says it in the answer.
Yeah.
What year is this?
Hey.
It wouldn't be 1966 by any chance, would it?
I don't know.
Like, where's the Cannes film? Where's the Cannes Film Festival being held this year?
Yeah, that's right.
I don't know.
Yeah.
Okay.
I'll have to look that one up.
This is a person. Okay, question 2. This is a person in history.
Okay. So it's a who and
This
it's
person?
a what and it's a who.
Oh,
No,
it's
just a
person.
who.
No, the first one was
Just
a
a
what.
who.
No, that was a year.
Well, it's a year.
Yeah, what year? Yeah, what year is it?
It was a number.
This is a who.
Yeah, this is a who. Yeah.
So this person has the same name as a mother, and that's a sister named Bernice.
Haven't got the foggiest idea.
Murdered.
Well, I wasn't. Oh, funny enough, I wasn't going to give the easiest question first. Easiest clue first.
Okay.
Otherwise, it'd be a very quick quiz. Okay, question 2. Sorry, clue 2. She became and has been a pop culture icon that should be for many years, spanning originally the Middle East and Europe, spreading to the world. No clue.
That sentence doesn't make any sense. I don't understand.
Oh, I think the grammar bit's gone.
Well, let me rephrase it. She was a pop culture icon.
Yeah.
That originally came out of the Middle East and Europe and then spread to the world. Does that make
Yeah,
more
that's
sense?
what I read.
Yeah.
Yeah.
Well,
that's
she
what I read.
became and has been a pop culture.
Oh,
has
yeah,
be-
she
has
became and
been.
has been a pop culture
Has
icon.
been, not being.
Been.
Been.
She
It
has
has been, not
been.
being.
Bean. She's a bean.
She has being.
She's a bean.
Not being. Bean. Like
You still
baked
haven't got
bean.
the answer
Baked
right.
bean. Like baked bean.
It's
No,
a
that's
shame
the-
spell check doesn't also sometimes catch the odd grammar mistake, isn't it?
Yeah, exactly.
I think I'm doing well if I get the right letters at the
Yeah.
start.
Stop picking on Timbo. He's only a
I'm sorry.
He's only a turtle.
I'm sorry.
You know,
I'm sorry. Couldn't help
Look, don't worry. I've been picked on. A lot of people pick on me for my spelling.
it.
I do a lot of wonderful things for computers, but spelling isn't one of them.
Yeah, same.
Yeah, don't give up your day
She
job.
never starred in a movie, but a number of movies have been made about her. There's a big clue in that.
Mm.
The most well-known only made $1.9 million at the box office. No correct answers yet.
A lot of movies being made about her. Middle East and Europe.
Okay. Moving on. Although highly associated with the country of her birth, she is unlikely to have spoken her native language in her early life. She would have spoken Greek, most likely.
I thought it said creek.
Greek. Creek? It does say creek. It should say Greek.
Now he's taking the mic.
No, it should say Greek. It does say creek, though.
Yeah.
I don't think I have my glasses on when I wrote this.
Yeah, it's all creek to me.
It's all Creek. Yeah.
Still Greek. Still no correct answers yet that I can see. No, she didn't star in a movie, Truth Notes, but the movies have been made about her.
Yeah.
Okay, next. This person was born about 2,000 years after the Great Pyramids of Giza were constructed. 2,500 years, sorry.
Yeah.
That should be a huge clue for those who know when the Great Pyramid of Giza were constructed. No. No. Okay. Moving
What
on
about that
to
one?
this.
Is that
It
it?
should be that one. Oh, no.
Ah,
Oh,
Getting, but you're sort of on the right track, Terry.
I'm
You're
on
sort of
the right track.
Sort of,
Okay.
sort of. Okay. Yes, we've got some answers out there. No correct ones yet. Okay. Next. Notably, she hung out with Alexander the Great. That should give it away.
Okay.
yeah. I
No.
was just typing the answer before you actually said that clue there. So I think it's that.
Room. No.
No.
Broomfondle has the answer out.
Yeah, but he's got two answers out there. Which one do we pick?
Yeah, which one? Which one?
Well, the latest one, and Clive Wells has it correct.
Actually, Crumpy Old Gunk got it even earlier.
Did he?
Did he?
Yeah.
Did he?
Where?
Crumpy?
Look up from Room Bundle.
From Crumpy.
Oh yeah,
Crumpy. Oh yeah,
yeah,
did.
Grumpy
Sorry.
Gun.
I
Yeah,
missed
yeah,
that one.
yeah.
Sorry, mate. I did miss that. I didn't see you write that one. You did write that. Yes.
Oh, okay.
So yes.
Okay, Crumpy.
So a common belief she committed to a beaten by an ass, but no snake was found with her, and she noted probably just used an eel or greater to introduce the poison through the skin. Yes, it was Cleopatra. And the interesting thing is that she grew up in a city, and this Greek city, which inside Egypt, which I can't remember the name of, but speaking Egyptian was considered too common, so they spoke Greek.
Oh.
I like that clue. She never starred in a movie. Yeah. Okay.
No, she never starred in a movie.
No.
Even though that the movie, which was a big box office winner at the time at 1.9, 1.9 was 1.9 is only relative.
We could say that was a trick question, but that was a trick clue, sort of.
Yeah.
Yeah, it's a trick clue. Yeah.
Yeah.
Okay. What is this decade? This is a decade.
Is another what? So who, what? No, what?
When?
Does it matter, Terry?
When did I say it was a what?
No, it was a.
Who you to tell me when I say it was what?
It was a when or
it was
what?
A who, then it was a what.
It was a what, or was it a who?
Okay. What decade is this? You know what a decade is? Good.
Yeah.
German physicist Rudolf Clausius, whatever.
Clausius.
Clausius, that's the one. And I thought Paul might get this on first clue. Published his paper on mechanical theory of heat, on the moving of force of heat, which first states the basic idea of the second order third dynamics.
Not a century, do we?
Decade.
No, decade.
Decade. Sorry, damn.
Decade.
I was going to narrow it down.
Well, if you narrow it down
first
to
YMCA
the century, just pick a decade.
Yeah, if you start off with a century, and then you've got 1 in 10 chance of getting that right.
Yeah.
The first YMCA in North America is established in Montreal. Oh, Alan is very close, but not quite. Hang on a sec. I've got another clue out. Writer Oscar Wilde is born. I can tell you there is a correct answer out in the Peanuts.
Oh, already?
Yeah. Which will mean I'll move on a little bit. The National Dress Reform Association is founded in the US to promote the rational dress for women. But you all knew what year that was. The United States presidential election, Democrat James Buchanan defeats former President Millard Fillmore, representing a coalition of know-nothings and Whigs. Blah, 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 blah. Becoming the 15th president of the United States. Victoria and Albert Museum in London is officially opened by Queen Victoria.
That narrows it down.
I haven't got any
So
other
Queen
correct
Victoria
answers
was alive.
in the... Oh, sorry, yeah. Alan has the correct answer in our internal chat. So, sorry, Alan, I didn't see that pop up.
It isn't fair. I want
not right.
some answers. I want my share.
Okay. This decade, well, if you can't work it out from that one, you don't know your Roman numerals.
Well, I don't, actually. I know what XLIX is.
Yeah. So what is the first one then? Look at it. Talk it through, Terry. Talk it through.
I don't know what M is, or D, or C.
1,000. M is 1,000. D is 500. C is 100. So 1,000 plus 500 plus 3 100s is
18.
1,800. Right.
And X is 10,
Then
and L is 50.
X, yeah. So L minus X gives you 40. And
9.
X minus
9.
I gives you 9. So
49.
1849. So it's after 1849, but before
1850s then.
51. 1850, yeah. So there you go.
So I was right.
So are you all right?
Yeah.
Where's yours? Where's yours? Where's
Well, I got
yours?
the 40s, but the wrong century.
Oh, I said 20s, but
Oh,
I
there
didn't
you
say,
are.
I didn't
Sorry,
say
yeah.
which 20s in which century.
Yeah, I gotta blame Matt for that, Paul. Yes, you were right. I'm about to make this bigger.
What?
Because
blame me? Why?
no, because
What?
because I only had about 4 lines open on my chat. So you put your answer in, push Paul's answer off the top.
Oh, it was my fault. Yeah.
So it's your fault.
Guess who always gets the blame? Matt always gets the blame.
Yeah, me. I always get the blame. Even when I'm not here, I get the blame.
Yeah, even
So,
when you're not
so
here.
that Paul off the top of the stack, did he?
So Paul was the first
Yeah.
one internally to get the correct answer.
Okay.
There you go.
Okay. Okay. Moving on. Next
So
one.
What about the nuts?
ahead.
1850 is the correct answer, and it was picked up pretty early by Grumpy,
Grumpy
I
Gun.
believe.
Grumpy.
Yeah, Grumpy Gun. Yeah. So my wrong answer knocked Paul's right answer off the top. Is what you're saying.
Off the top of my screen, yes. Okay. This is event in history, funnily enough. This event, and try and do this without a calculator, 15,134 days before Pluto was declared not a planet.
Oh, that wasn't that long ago as well. The Pluto. Yeah.
Okay, next clue. This event was 6,720 days after the first image of Earth from space. Happy fair to guess. Next clue. 499 days before England last won the World Cup.
So that would have been 1964.
Yep. Next one. We'll do this one relatively quickly. 463 days after JFK's speech, we will go to the moon. You may notice a little bit of a theme in most of these clues. So, as a clue in itself.
There. Oh, who's typing so fast?
No, no, it's not that, but you're close. Sort of.
Stewie said my birthday. No, I'm a bit older than that.
No.
Stewie.
Sorry, Alan. No, that's all right. I'm just checking there's no answers out, and no, not quite yet. Okay, next clue. 77 days before Ed White took his 20-minute swim in space. What was 20? So it was a couple of months before that. People a few seconds just to sort of put things. Next. This event ended 12 minutes after Vesky left his spaceship, during which he ballooned and was no longer constrained by his spacecraft and internal atmosphere. He could not re-enter the airlock, leading the suit beyond its safety limits. No. What was 12 minutes after? What ended 12 minutes after Leonov left his spaceship? What ended? Yes, that's it, Alan. Have you worked it out yet? Yes, that's it, Paul. Anyone out? I haven't got anyone out in the
Truth knows, that was just
No one
me
out?
typing the answer.
Yeah, we can hear it from next. Hear it all the way from here.
So I haven't got any correct answers out in the peanut gallery there. Did you get it yet, Paul? I mean, Alan, Alan and Paul both got it. Sorry. Did you get it yet, Terry? That's what I was trying to say. Okay, let me walk it through. Okay.
I think some of you might have got it.
Is the first person to leave his space? Yeah, they have. You both got it. I'm just trying to walk it through for Terry. He leaves his spacecraft, Terry. What was he doing when he left his spacecraft?
That. Oh,
Apart from
Yeah.
shitting
I
his
spelled it
pants.
wrong. I'll try
Apart
again.
from nearly dying. So for the peanut gallery, it was the first walk in space, or first space work, or EVA, or however you want to pronounce it. Okay. Did no one got that? Did I miss? I didn't miss
Yeah,
somebody.
Clive got it out there.
Did he? I didn't miss that one then. Oh, it's
Yeah.
already is. I see it. EVA. Yeah. Okay. Now, question 5. What am I talking about?
Oh, I missed the last bit of that last one. There, I was talking. Sorry. What was the answer?
Oh,
Spacewalk was it? Or?
yes,
Yes,
yeah.
yes, it
yeah.
was. Yes, it was, Matt.
You were just talking about it when I went off. Yeah.
Ah.
Didn't get my answer
Yeah.
out.
I mean, Timbo, that's like asking what ended in 1960.
Yes. Yeah.
1959.
Yeah.
1959.
Yeah.
No. Okay, what am I talking about? This is not as timey as the other Wimies are. Okay, I'll go through this one relatively quickly. So we'll see who can get it first. This word comes from the meaning of west wind, from the Latin and Greek Zephyrus. Zephyrus? Zephyrus. I think it is.
Zephyrus.
Zephyrus. Zephyrus. Zephyrus. That's a. Introduced to Europe around 1200 BCE. Let's see who can get it first. Let's have a race between the internal chat and the peanuts. Okay. Next. Many people doing very high level mathematics encounter this number often. Let's see any answers yet. Number. This number cannot be defined using Roman numerals, so it should be good for Terry. No,
Well,
Alan, that's
Paul
not
should
it.
get this one. Very high level math.
You should. You probably get it in the next one. Just remember, I am a bit twisted.
Yeah, noticed.
Danny Matthew of Fibonacci, who grew up in North Africa. Is credited with introducing the decimal European system to use the term Zephyrum.
Oh, there you go.
We have. Yes, we have a correct answer, both out there and in here. Usually, number we usually leave you with nothing.
Ah, yeah. I would have got it with that.
It's because Zephyr in Italian is often contracted to 0 in Venetian.
Zephyro,
So,
yeah.
0. So the number is 0. And would it be true to say many people doing very high level mathematics encounter this number often? I would hope so. Like every other number. It was just a red herring. Okay, what am I talking about? Question 6.
I have no idea.
Ooh, that's the same.
Oh,
question.
0.
Yeah, that's easy. Got that
Yeah, I got that one right.
What am I talking about?
one.
Question 7. The length has maintained its mean, but its length has often been corrected.
Well, we should have asked Riley that question.
The word.
He wouldn't have
I
got.
might just
he wouldn't have
rephrase it.
He wouldn't have
The
got zero.
word has maintained its meaning. Yeah, sorry, I was just going to say the word has maintained its meaning, but the length is often corrected. Although most people on Earth relate to one particular length of this thing, but depending on what you are looking at, it varies greatly. No, a meter does not vary greatly. People are assigned one of these when they are born, and they cannot change it no matter how much they want to. Terrible grammar, yes. That's how you know I wrote it myself. If you were on Pluto when it was first discovered, you would not have yet seen a complete one of these. Yes, Alan's got it. I don't think we've got any correct answers out there. Okay. Next clue. If you had 3,000 of these, you would have a tamillary. You'd have a word I can't pronounce. Tamillary. I think it's tamillary.
Teluminary.
Tamillary. And you should get it from the next clue if you haven't got it already. 1,000 of these is a millennium.
Oh yeah, well yeah.
Yes, it is a year.
Yeah.
Everyone is given a birth year. They can't change it. I mean,
Who was first out there?
Funny.
Age.
It was pretty late now. Clive Wells.
Oh, this time.
Yeah, Clive.
And Alan got it internally. Okay. Year of birth came after, literally. Yes, just a year.
Yeah, well, I got
Question
birthday
8.
and then I said year of birth, so I kind of right the first time around, sort of.
Yeah.
Sort of.
Okay, what I am, but you've got to say the words.
A turtle.
What am I?
You're a turtle.
Everyone alive on Earth is technically one of these. That's not the words I'm looking for.
So we're not all turtles.
Okay. Earthling, no. Human, no. And we're not turtles.
Oh, I know.
Okay, this was proposed by a scientist, name unknown, in 1895, but fictional works prior had proposed the possibility. Stumping people again. Okay. A very well-known doctor adopted this profession. This doctor once quoted, some people live more than 20 years than others do. Sorry, some people live more in 20 years than others do in 80. It is not the time that matters. It is the person. And Paul has it correct already. Okay, next one. Claire Abshire, this will be a bit cryptic, we'll test your knowledge here, was married to one of these and her daughter Alba became one, but she, that's Claire, never becomes one. Yes, Clive has it. And last, and you should get it from this one, 1984, the Terminator, 2 of these arrived from the future.
Oh, yeah.
Okay, yes, that's it. Anyone hasn't got it yet? Time travelers.
No.
And anyone know the scientist? Name unknown?
No clue.
That's because in the book, The Time Traveler, the scientist's name is not known. The main character is only known as the Time Traveler.
Oh.
Okay.
Yes, but it's all written in the first person to him, isn't it?
Yeah, that's right. So we don't know his name. Okay, just for a change of pace. Okay, let's see if you can solve this this little pattern puzzle. So what time should the last watch show? And Doctor Who was a time traveler. Yes, he was the Doctor. Okay, anyone? Any clues? Pick a number. I will tell you that it is in the 12-hour format, not 24-hour format. And I have any correct answers to make your life easier. There are more than one answer. Give me any answer.
No, I can't figure it.
Okay. When you say it, you'll think it's not actually that hard. It's not a particularly cryptic one.
Yes, it is.
Low battery, no.
Low battery. Error.
Yeah, 404.
Okay.
Error. Yeah.
404? Did someone put 404?
Yeah, I said 404.
Error.
That's
404.
That is a correct answer.
Really?
Was that a guess, Terry?
Completely by accident, but that is a correct answer.
Oh, do you want me to explain how I got it?
Yes.
I'm not going to give it to you.
Spooky bed here. It is in time format, so if you can give me that in time format. Okay, so 4:04 is 4 minutes past 4 is a correct answer. Will I give you some other correct answers?
Yeah.
6:02 would be a correct answer.
Okay, why?
7:01 would be a correct answer.
Why? No, I'm just asking why.
Yeah, I know.
Why are those correct answers? It's a genuine question.
What?
I wasn't trying to be funny.
125. 125 is a correct answer.
Awesome, but why?
Actually, if you switch the second digits, the 2 digits after the colon, all those would be a correct answer. No one's got it.
You got it yet, Matt?
No.
Yeah, I have now. Yeah. I'll put my correct answer.
That would, yes, Matt, that would be a correct answer.
Yeah. I'd hope so.
What did you do? Switch the last 2 digits?
Yeah, pretty much.
He didn't actually do that, but what he's written is a correct answer, yes.
Oh, okay.
Yes, Stark Older would be, that is a correct answer. There's lots of them. Yes, Clive Wells just worked it out. So they've worked it out in the peanuts.
Yeah, that's exactly how I worked it out.
Yeah, that's how I worked it out too, Matt. That's why I thought I'd do an easy one, 404.
Yes, the numbers just add up to 8. That's all it is.
Oh.
Nothing. They just add up to 8. Think hard.
Did anyone out
Sometimes
there get it
the hardest.
easier?
Yeah. Yeah. Oh, and us. Yeah, no. Matt was the only one who wrote the correct answer. in that chat.
Start order.
Oh, Clive Wells wrote down the right answer, didn't he?
Did he?
Digits sum to 8.
In the chat?
Yeah.
Oh,
So-
out there or in here?
Out there.
Oh, no, sorry, Clive Wells. Sorry, yes, Clive Wells got the right answer. Yes, sorry. Yes.
Yes, so
No, I said
any combination of switching those numbers around will do it though, because they're all add up to 8,
Yeah.
so it doesn't makes no difference what you do with them.
Judy said they
Yeah,
all add up to
that's right.
10. Where'd you get your maths from, Judy?
Okay, moving on. I thought for the very last one, I had thought that farmers might be here. He tends to like these questions. I'll do something a little bit more lighthearted. And you can tell me who wrote these or performed these time-based songs.
Oh, where's Farmers?
Ooh.
He's good at this.
Yeah, farmers
He
is
need
good
to
at
do
this.
Okay, I just realized I've made a very big blunder here.
Oh,
Okay.
no.
Let's see how quickly you can get the answer correct. And since it's late, it's probably a good idea anyway. Who wrote "Time Is on My Side"? First answer. Anyone?
I can see the answer.
Yeah, I was just waiting. Still haven't got a correct answer.
I'll type it.
Tony Captain got it right out in the sort.
I just typed
Okay.
it really quickly. I spelt it completely wrong. Rolling.
Okay, I could turn back time. Who read that?
Oh,
Who
that's
did
easy, that
Perform
one.
it? Quick. Yeah, no. Okay, yeah.
Yep.
Well, you've already got the answer on the screen.
Ah,
Yeah, no, that's what I'm saying. I forgot to put it.
oh,
Oops.
The cat's in the
may as well
cradle.
just-
Come on.
You may as
come
well
on,
just ask
quick,
the question
quick.
and not show it.
Yeah, just read it out.
Yeah, no, hang on. I got to unshare. Let's stop sharing.
Yeah, you may as well unshare it.
Okay.
Otherwise, we're going to see the
Okay.
answers.
Did anyone get the Cats in the Cradle? Who performed Cats in the Cradle?
Oh, I don't know who that is. I don't know.
That was Harry
That's it.
Shafting, wasn't it?
That's
No,
correct.
I
That's the
thought
correct
Bruce
answer.
Fondle got the answer for that. Cats in the Cradle. Oh, Cats. No,
Did
it
he?
wasn't
Cats in the
Cats.
Cradle? Did he write Harry Shepard?
That's what you had
That
anyway.
is- That is the correct answer. Even got into the Hall of Fame with it. So, okay. I've had the time of my life. You can tell me either who performed it or what movie it came from.
Oh, yeah, the movie. Had time of
The
my
time of my life.
Yeah,
Never thought this
yeah, I've got it,
way
I've got it, I've got it,
before.
I've got it, I've got it. There. That's the movie.
I don't think most people will know who performed it.
I'm not sure who.
Oops,
performed it.
I've lost my thing. Where's my thing gone?
Oh, somebody's putting shoes on to go into work.
I've got the movie, but I just can't think who
Who
sung
did
it.
Sorry,
Who's saying it? Yeah.
I've lost the Zoom chat.
Oh,
Where
no.
are you? There it is. It was buried under 15 screens. Okay, getting back. Yes, that's correct movie. I knew you would have had a correct movie, but I just couldn't find the chat to check. Okay, the performer was Jennifer Warnes, Warnes. Jennifer Warnes.
Jennifer Waters, but it was sung with Bill Medley, apparently, according to my
probably.
my missus. Yeah.
Ah, yes, that's probably correct.
Oh, you got
Okay.
your brains trust there.
Mrs.
to answer
Yeah,
this.
I got my missus helping
Well,
me.
you can ask her who performed Time After Time.
Who
Josh will know
who sang Time After Time, Nina? Her era, she likes all that music, so she should know. Oh fucking hell, she says. Oh no, you can't say
What?
that.
Tell her I said
Yes,
swear jar.
Paul's
You have to
Paul's
put,
got
you have
it
to put
correct
money in the
already.
swear jar, Paul, Terry says. She said you can go yourselves.
Paul's got it correct already in the chat, in our chat. Ah, sorry. I put up the what's he chat. I can't see what the Peanuts are doing.
How far's Armageddon
Close
Five
to
behind you?
streak.
Cindy Lauper, she says.
That is correct. You can tell her she's correct.
Correct.
Yeah,
But
I think Spook got it.
tell her that you said the answer too slow.
You said it too slow, though. You said.
No,
talked straight
you said the answer. That you
I
said
said
the
that.
answer too slow.
As soon as you said it, I told you. What are you on about?
Because Paul got it in before you did.
Yeah, Spook got it out there.
Yep, he did. Cindy Lauper is the correct answer.
Yeah.
Okay. And last one. Good riddance, which is time of your life. There you go. Work that one out. Good riddance. You'll know the song if you hear it.
Good. Who sung Good Riddance? Good Riddance. Is that the name of the song? Is it Good Riddance?
Yes, but you may know it has time of your life in the lyrics.
What's wrong with your turtle?
What do you mean? What's
Well-
wrong with my turtle?
Are you missing half a flipper?
Yes,
Green Day, apparently. Green Day.
yes,
Oh,
Yes.
that is correct.
Yeah. There you go.
I didn't know that one.
Green Day. Look it up. Those who don't know it, you'll hear it. You'll know exactly which one it is. So there you go.
Oh, thank you.
I've stretched this
Timbo.
out to 12:30.
Yeah.
Thank you, Timbo.
I don't know which quiz hurts my brain more.
Now I got to think of a theme for next week.
It's on the album
come on,
She's
son.
So Unusual.
That was fun actually. That was a good quiz. I enjoyed that.
Yeah.
Bit of variety in it as well. I like a bit of variety. Variety is a spice of life.
Variety is the spice of life. Yes. Who said that? I don't know.
Lots of people said it. I said it just now.
Yeah, you said it.
Yeah, just a minute ago.
Well, mumble away while I just grab these.
Mumble, mumble, mumble.
Blah 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 blah.
Blah, 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 blah.
Santos.
Oh,
Fantastic.
I didn't say Simon could talk yet.
Hey, can you get...
Go over there, you. Oh. Grab that.
So do you get this sound if I play it? I'm just curious. Do you guys hear that?
Only if it's
No.
the sound of silence.
I can't hear what you say. Did you guys get what I played through?
Depends what sound thing you've got.
Yeah, no, I was just going through OBS. I just wasn't sure if that came through or not. So if I push that and push this, you won't hear that. Hang on a sec. What are you doing? There, that's it. Can you hear that?
No.
Hmm. Ah, curious.
Hmm.
Let's send time forward. I'm time traveling.
Or as he calls him.
I ended up with 2 Simons. How'd that happen?
Yeah, I'm having a meeting of fellow time travellers, Timbo. We're meeting last Wednesday.
Oh, oh, were you? Good. How was it? So, in the current theory of time, it's not. Is it still not possible to go backwards in time?
Not possible. That's correct.
Yeah. That's my understanding.
Couldn't we say unknown?
Well, we could, but that wasn't my question.
Unless you're an antiparticle in a Feynman diagram.
Well, you already asked that question, so I've gone back in time.
You come back in time. Does the past exist?
It did.
Yeah, it did, but does it still exist?
Oh, it's gone. Sorry, the moment's gone.
What question did you ask?
It was in the past. My original question was, in the current theories of time, is it true that you cannot go backwards in time?
So if you asked that question before, then clearly time, the past does exist. But if that's the first time you asked that question, then we don't know if the past exists.
No, doesn't that only prove that the past did exist? Do we know whether it's still there?
No, the Langoliers come and eat it up, right?
I remember an episode of The Twilight Zone where they had the in-betweeners that would set everything up between each moment in time. And somehow the person accidentally fell into the gap between time with all these backstage people, moving things around and stuff like that. And they pointed out, when you lose something, where you think it was there and then you look and then it's back, that's because they forgot to put it there. And then in the next moment of time, they put it back so that you find it. Do you remember seeing the past? Yes, obviously. You can remember seeing the past, but that doesn't necessarily mean it was still there. I still remember seeing pictures of things that now no longer exist. But they obviously did exist.
Timbo, don't you need a bit
Yeah.
more room to the left for your turtle's flipper?
Yeah, that's
On
what I
the,
said.
Yeah.
He's got half a
Alright.
flipper.
My flipper's running off, yes. Depends what I've got up. Let me get rid of the solar system. Okay, I'm about to destroy the solar system, everyone. Go back into here. Where are you over there? Oh, let me pick up that origin. Oh, my origin's gone off. That's why.
There we go. All set up. I haven't got 4 tabs open. What's QFT?
Quick file transfer.
Right.
Quantum field theory.
Clever people stuff.
QFT?
It's still clever people stuff, isn't it?
uh,
Quietly fast train.
you showing your plain thumbnails again, Alan?
Yeah.
Plain as in PLAIN.
IANE. I'll spell it for you. How's that?
No, plain. PLAIN.
I thought it was PLOIN.
No, I'm using the other usage of the word meaning.
Although it's not supposed to be just showing the aeroplanes, it's supposed to be showing all of me images. But, you know, never mind.
Which is life.
Have you got an original image of that plane that's in Fair Suck that was modified? One that's not modified?
Let me yeah, I'll find you a picture of one, just a second. Because it's a bit of a joke, isn't it, that there's a Twitter account called RAF Luton, and everything is, all their photographs are taken from one of them. Well, an original one.
I'll just pop it up for the peanuts so they can know what
Yeah, I
I'm
will do.
talking about.
Just
Yeah, I'm just
I'm-
popping out. I'm just popping up
Yeah.
the other one, just so the peanuts can see what I'm talking about.
Oh, there we go.
That might be a better picture.
Properties.
So that's the one I'm talking about. It's modified.
One of those. Well, that's the Mark 9 photo reconnaissance version of it, but there's also bomber versions of it and quite a few of those too. And that's the original. That's the English Electric Canberra. And that one was actually built by Short Brothers Harland and Wolff. In Matt's location.
Put up some pictures of electric planes and fair suck for you, Alan.
Yeah. Yeah. And I'm not quite sure how great a plane that photo of a plane is, because doesn't look too planar, does it?
It's the Great Plains.
It might have a bit of a dip in it.
Planes are not flat. Full level. Or horizontal. Did I tell you my uncle once came third in the world aeronautical acrobatics in a tiger moth?
Yeah.
Yeah.
That's actually really good going, because a tiger moth isn't particularly aerobatic. I mean, they'll do aerobatics, but they're not particularly
I'm pretty
aerobatic.
sure it was a tiger moth.
No, I'm not saying you couldn't.
No,
I'm
I'm
just
just
saying-
sorry. I'm just thinking to myself is that there was I would send you a thing, but it might sort of dox me a little. Since it has his name.
Yeah. There's I mean, unless it was before 1940, there's lots of other much more likely aircraft that I would guess that would be used to win a World Aerobatics Championship.
I think it was a particular event, like not an open event, but it was for the for a biplane. I don't know if it was for biplanes. I'm just trying to find out what the actual event it was, but it was in the World International Competition.
Because one of the world's most successful aerobatic aircraft, competition aerobatic aircraft, is the Pitts Special, which is actually usually a home built type.
Yeah.
Designed by Pitts, and that was designed in 1940.
Okay.
And they're still competitive today.
Right. Cool.
Although stuff like the extra 300, which in the roll round of pictures that was going on, there's a red and sort of smoke black transition painted single seat aircraft with some sparks and stuff coming off the wingtips. They've got a bit of an edge over the old Pitts, in so much as they're rated for plus and minus 6G.
All right.
And can roll. Yeah, so that's literally do an aileron roll around the longitudinal axis at 540 degrees a second.
Okay.
And yes, I did say 540 degrees a second.
A second. Yeah. It's a lot.
Yeah, I can get a ride in a two-seater version of one of those from my local airfield about a mile away, sorry. But it's going to be about £300, and I'm gonna have to lose about 10 kilos in weight.
James W. Rogers, convicted murderer, when asked if he had a last request before dying by firing squad. Yeah, I already done told you. Bring me a bulletproof vest.
Okay. We'll shield Matt's channel. He needs more subscribers. He's only got 1.81K.
Well, it's for Timbo. That's why.
Yeah, it is.
Yeah.
Oh, okay.
Can I do the honors?
Yeah, you do the honors.
Can I do the honors? Because I really want to know. Can you push play?
Just hurry up and do it.
Do
Push
what?
play, come on.
Oh, press play.
Press
okay.
play.
Okay. Pressing.
Hi, Matt here, and welcome to M2M and
Oh,
this
hi,
episode
Matt.
of Quick Questions. I had a question posted on my Discord from Timbo Total, and he asks, we don't hear much about what the Chinese are finding on the moon. Have they found anything interesting? Well, yes, Timbo, as a matter of fact, they did, and I'm pretty sure I can answer this in under 3 minutes. But before I do, Timbo Total has his own channel, where he debunks flat earth things, so go check out his channel, maybe give him a sub and let him know who sent you. So let's answer this question. Start the clock. In 2019, the Chinese National Space Administration, or CSNA, as I call it from now on in, landed a probe called Chang'e 4 on the far side of the moon. It then deployed a little rover called U2 number 2, or U22. Not long after the rover deployed and started taking photos, one image caused something of a stir among both the scientific community and especially among our conspiracy theory friends, and what appeared to be an oblong-shaped object on the lunar surface, which was labelled by the CSNA as the Mystery Shed. Theories as to what it was were both wild and weird, including alien buildings. But of course the CSNA were going to investigate this strange object. So, without further ado, controllers commanded U22 to make a series of manoeuvres to get it within better visual range to find out what it was. Well, the final image did satisfy that it wasn't a building or anything oblong in shape, but it was a rock that resembled something the shape of a rabbit. Well, of course, I'm sure this created even more wild theories. Another discovery of more scientific nature found that as the U2 rover moved around the lunar surface, it was noticed that the rover's wheels were slipping far less than on the near side of the moon, which suggested that this part of the moon was flatter in geography compared to the near side. It was also noted that the craters seemed to be smaller on average than on the near side, but most of those craters appeared to be secondary impacts from the larger impact craters, rather than separate impacts themselves. There also seemed to be more craters than the near side, but it was thought that this wasn't from more impacts, rather than the near side had much more volcanic activity in the early years of the moon's life, washing out, for want of a better phrase, many of the craters on that side. Further to that, it was found that the lunar dust seemed to be clumping more readily on the wheels of the rover, more like soil, and after some analysis it was found that this lunar soil on this side of the moon seemed to be stickier in nature compared to the near side of the moon. According to this New Scientist article, the Chinese scientists had claimed they had discovered more about the nature of this soil, but declined to comment any further for whatever reason. So I hope this answers your question, Timbo. Stop the clock. So that's all from me. Until the next time, stay safe.
Thanks for that, Matt.
So did it answer your questions?
Yeah, well, the question was what had happened with the Chinese, because you don't hear much of that from this.
There was something I neglected to put in the video, actually. Somebody in the chat might know what it is. Yeah, I should have
Is
mentioned.
that about the material, the element they found?
Well, sort of. It's glass beads.
Yeah.
They found glass beads, but
yeah,
it's not that unusual because they actually found these glass beads actually with the Apollo missions, obviously on the near side of the moon.
Right.
But the Chinese are saying that they think it's more to do these glass beads were formed with impacts rather than volcanic activity, which they thought formed the glass beads on the near side. Because apparently, from what as I understand it, glass is actually formed with extreme heat, but then cooling very, very quickly, which I think is more aligned with, big meteor impacts than volcanic activity. Because for what I understand is the volcanic activity on the moon took many hundreds of thousands of years to settle, or even millions of years possibly. So it makes more sense that, it was a meteor impact. It hit, there was a lot of heat, and then it dissipated very, very quickly and then formed these glass beads, which I think maybe the Chinese are correct. Maybe, I don't know. but maybe it was formed from volcano. I don't know enough about the science of it, to be honest. So I don't know.
Clive says glass beads.
Dome fragments, yeah. Yeah, I just seen that. Behave. So yeah, I forgot to put. I could have put that in the video because I still had 40 seconds left, didn't I? So, but I totally forgot about it. Never mind. Oh well.
Always make a part 2.
Yeah, could do. But I won't.
You won't? Okay.
No, there's no point really.
Flat Earth proven by Kansas. Okay.
Oh, is this Clive Anderson? Yeah, Clive Everett. Sorry, not Clive Anderson.
Is he related to Kenny?
How about Everett Anderson? Try him instead.
Everett Anderson, even, yeah.
Try him.
Anyway, Terry, you want to press play?
Oh, yes, I could do that.
Shut the globe Earth believers down in this video. So listen up. First, gravity is only a theory. You can look this up for yourself. Gravity really doesn't exist. Gravity is just density.
One day you're going to be the most famous clown in the world. Make him laugh.
Gravity is the thing that they had to put in front of us to make us believe that we're on a spinning ball moving at 1,000 miles per hour.
Ain't life a motherfucker?
It's got nothing to do with it.
Yeah.
Objects that are more dense than the medium it occupies will sink to the bottom. In an air medium, we fall to the ground because we're more dense.
What are you fucking
What about an alien balloon?
I think he's more dense.
What's in it for them? Just think about it. If the Earth isn't really what they say it is, that means everything we've been taught to believe about this planet is wrong.
Oh, so the Earth is flat and all the other things in the sky are round.
You've never seen a 360-degree view of any of those things with your own eyes. Only CGI pictures.
You will amount to nothing. Nothing but a clown.
This planet isn't really what they say it is. That means the celestial bodies above us aren't really what they say they are.
Are you happy to be a clown for the rest of your life?
People still believe in NASA and all of the information that it produces.
What, just NASA?
Me?
Behind me is a picture of our Earth and Moon, according to NASA. They apparently sent a telescope beyond the Moon and pointed it back at our planet to give us this photo.
It must be obvious day on Camp Stupid.
Take a look. Do we not see this? Do we not see this? Does that not scream CGI?
What? No, it
Behaves
screams
like this on a moving surface.
It screams photograph, actually.
1,000 miles per hour. Why do we experience this? How is it possible for smoke to rise perfectly upward on a spinning surface?
God damn it, are you fucking with me?
Bro, the atmosphere moves with the planet. The globe is spinning at 1,000 miles per hour, so that means the atmosphere is spinning at 1,000 miles per hour.
This is 019er requesting permission for approach to smash into brick wall. Over.
Permission granted!
Right on.
Really ask yourself if that makes sense.
Hey man, just open a science book, you dummy.
Why not? Stop clinging to beliefs that were forced down your throat at a young age. Most of the stuff we learn in school is bullshit.
No, no, no!
Rough on him now.
No, he needs to know.
Okay.
He's always crying.
Right, tough love it is, tough love. Wake up, idiot!
Drop some actual flat Earth evidence.
It is no laughing matter.
A common phrase in Kansas is this state is as flat as a pancake. So these scientists literally got a pancake from IHOP and used confocal lasers to map the topography of the surface of that pancake.
Oh, this again.
Perfectly flat surface will have an F value of 1. Their pancake had a flatness value of 0.957, almost flat but not perfect. Kansas, on the other hand, had a flatness value of 0.9997, fairly close to platonic flatness.
Life? What life you talking about? I ain't got no life.
Kansas has a width of 410 miles, approximately 660 kilometers. On a
I'll let
spherical
Blue
Earth,
in, Alan.
400-mile distance will have a curvature of 20.2 miles. However, there was no curvature measured in any shape or form.
I thought you were stupid, friend. But I underestimated you. You were a total freaking retard.
Yeah, TikTok flirts with such amateurs. Did we do a
have
flat
to look
flat
at
Earth
what they actually
bingo?
measured.
Did we do flat Earth bingo with him? Did we get all the buzzwords and everything? Most of them. I know you might have missed out on a few, but and Paul said I would like to
Yes, they
see
use
that.
elevation.
I said I would like to have seen that Kansas-sized pancake.
Yeah,
Big pancake.
they used elevation data, so there's no reference to the curve of the Earth.
I heard that Florida was meant to be flatter than for topography
be.
wise. That's what I heard.
I don't know. Apparently, Kansas is pretty flat.
Technically, flat is the wrong answer. Smooth is what it is.
Yeah,
But,
sorry.
No, but they use flat because they're referring to a flat pancake.
So we can stop talking about Blue behind his back now. He's here. So shush.
Let's see. Shh.
Oh, you keep talking. Just it's okay with me. I don't care.
Yeah, I think Flat Earthers have said a lot worse things about Blue than any of us.
I don't know. I'm Blue quite sure of it. I don't know if Blue heard me before. It just seems a coincidence that all these doctor's appointments are when I'd stream on a Wednesday. I don't know why that keeps happening. You missed out on Lindsay.
Oh, it's always like we start to put Lindsay up, and then suddenly, I've got a doctor's appointment.
You had a blank whiteboard, and then he drew all over it.
Yeah.
Oh God.
Apparently, this is the final video. Apparently, that completely blows the globe out of the water. Completely.
Yeah,
and he can get four Nobel
prizes from it.
Yeah.
Really?
Yeah, he's getting a Nobel Peace Prize and stuff. Yeah.
Nobel Peace Prize.
I think it's isn't he getting fiction? Isn't he getting the Nobel Prize for fiction?
Yeah.
Don't you mean a Nobel Prize?
Nobel Prize, yeah. That'd be good. That'd be a good award system, the Nobel Prize of stupidity.
Ooh, 172.
Yep.
Oh, I got about a bazillion hours in one of those damn things.
I bet you have.
A bazillion That's a hours. nice one too. I like that. Right, I have to calculate that.
It's nice when you go to an airport and you speak to somebody nicely and they say, "Oh yeah, the code for the gate to get round onto the pan outside the hangars is blah 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 blah."
Tell everybody, Alan. Go on, tell us what it is. Go on.
I can't remember. That was 10 years. That was that was like 2011 or 2012.
They've probably got the same code still.
No.
Yeah, they probably. I think it was something like all zeros.
Well, don't tell me don't tell me their passwords are also password as well, or password 1 or something.
That's good one.
Oh,
1, 2, 3, 4, 5.
There's a commercial in fact there's a commercial airline based in the hangar, and there's a photograph of one of their airliners. It's an extra 300L.
What?
Well, if you know
extra 300 airliner, huh?
they have four. There's an air. It's an airline, a fully registered airline. They have 4 extra 300Ls.
Wow. All right, now you got to tell these guys what an extra 300 is. Yeah, I know.
We were talking about them a little while ago. It's one of the best aerobatic aircraft in the world. It's the 2-seater version that the guy has got one down at my local airfield. But that location, it's a display team called the Blades. made up of 4 former Red Arrows pilots. But it's set up as a full commercial airline so that they can literally take paying passengers up and fly them in not just aerobatics, but formation aerobatics.
Mm-hmm. Wow.
Of course, the 2-seater's a bit limited compared with the single seat because you're only allowed to pull, I think it's plus 5 and minus 4.5 G.
Yeah, something like that.
Instead of the plus or minus 6 that you can do one up in it.
Oh, you can do
I'm
plus 10.
talking about the 2-seat version.
Oh, okay.
I think you can get to about 7, just over 7 in the single seater.
No, over 10.
Oh crap! Okay.
Terry, I think you need to change the title of the show.
Yeah, I'll do that now.
Terry Davies Air Show 2024.
Yeah, okay, I'll change that.
Aircraft discussion.
Yeah, I'll change that now.
Oh, okay, all right.
I'm only joking. I'm sorry.
I get it. I see what you did.
It's only because I don't know anything about what you're talking about.
I know,
That's
neither
the
do
only
I.
reason. It's pure jealousy.
There's only a few people here that know what you're talking about, and you are the ones that are talking about it.
Look. Pulling force is so heavy in the aircraft that you weigh 10 times what you normally would. This is blacking out and flying into the ground territory for most people.
Yeah, you're only going to do that momentarily, but
yeah, very momentarily.
But the airframe is stressed for it.
Yeah, one of the, I'm not sure if it's Extra or one of those companies that makes these type of aircraft in Germany. One of the sales demonstrations is he'll climb up on the tailplane and jump up and down on it. That's the managing director. Because
yep,
it won't break.
How many questions did you get right today, Paul?
Oh, it wasn't me. It was Timbo getting the questions right today.
Oh.
Yep.
Yeah.
The Timbo's Wednesdays and Paul's Saturday.
Well, how'd you do, Timbo?
I got all of mine wrong because I'm a hopeless speller.
All my answers were correct. It's just that the questions didn't match my correct answers.
Yeah, the question was wrong, but you got the right answer.
Yeah.
What I liked, Blue. I had one question about an event, and the very last clue I had was when the guy was this event happened. We finished 12 minutes after the guy climbed out of the spacecraft, and that stumped a few people.
Did me as well, to be fair.
I thought it was more you described the end of the event.
Yeah.
And said the event started 12 minutes beforehand. But, you know. So,
there's only one thing that can happen after you climb out of a spaceship and get back in again.
Or you don't get back in again.
Or you don't get back in, one or the other.
In my defence, I was in a conversation with my fiance before I had a chance to answer, so I never got a chance to.
Yeah. Okay, I'll take that.
Yeah. I think that was the only one I got right. Oh, apart from 1966, yeah, that was the only other one I got.
1966, yes.
Yeah, and that was a stab in the dark because I knew it was plus or minus about 2 or 3 years. So
and Terry got 404 correct, but he still didn't know why.
Yeah, I didn't know why.
Yeah, 404 adds up to 8. Yeah, whatever.
Yeah, I didn't. Yeah, I knew it all along. I just didn't want to tell you.
Fun and games.
Would you like a bit of Anton? Original core of Milky Way galaxy found using Gaia telescope.
Gaia.
Well, it's either that or frogs in Chernobyl turn black. Here's what this strange discovery means. So
Oh, actually, that sounds interesting.
Black frogs in Chernobyl.
Yeah, black frogs in
or
Chernobyl.
the other one was update from Saturn's moon Titan, where we find life here instead. So I thought
either one of those two.
Yeah, the space one. I thought I'd like that one.
What, Titan?
No, the other one, original core of Milky Way galaxy.
Oh. I kind of like the Life and Titan one as well.
You like the Titan one? Any votes? Any other votes for Titan?
Sure.
Oh, where'd it go? Uh-oh.
Where did the frogs?
Oh, Alan wants frogs now. we're in an impasse now. Is it Black Frogs or is it Life and Titan?
No.
Hello, wonderful person. This is Anton, and today we're going to be.
Hello, wonderful people. Maybe the peanuts should decide.
I know the peanuts.
Hello, wonderful person. This is Anton.
They always.
Hello, wonderful person.
Anton, wait on.
Hang on, Anton. Wait a minute.
I'm just trying to pause it. Right.
Why can't the peanuts help us decide then? Because we're in an impasse. It's either Black Frogs or it's Life and Titan.
It's 1:09 a.m.
Hey, what?
That was Paul.
Thanks,
He
Google.
did something. I wasn't Paul. It was
9 a.m. It's not 9 a.m.
It was Timbo, was it?
1:09.
No. 1:09 a.m.
Well,
was Paul.
your
10
clock's
past
wrong.
bloody 1 in the morning.
It's 10.
Go to bed then.
10 past.
Get on with it.
And you're arguing about what video you're going to play. Come on, just pick one, man. Jesus.
Yeah. I mean, it's Terry's show. I'm sure we're going to get what Terry wants.
Get on, Paul.
Oh dear me! I think we should have competition. See how long
Just
we
play.
can keep Paul up for.
No.
Yes, play that game.
Press play quickly.
Press play, Terry. Quick.
Yeah, it's happening.
Hello, wonderful person. This is
wonderful
Anton, and today we're going to be discussing some of the new updates in regards to the upcoming mission to the Saturn's moon Titan. That's actually going to be answering a very important question, a question that's been bugging us for a very long time. Are we alone? Is there any other life out there in the solar system except for planet Earth? Something that's actually going to be also tackled by another mission we discussed recently, the Clipper mission to Jupiter's Europa, but something that specifically is going to be the primary mission for the upcoming mission known as Dragonfly. The mission that's going to arrive to Titan, and the mission that's going to be delivering something that we know is going to work here really well. A nuclear-powered helicopter that's going to be doing a lot of science on the surface. A Dragonfly spacecraft. And very recently, several studies have been published officially telling us exactly what the scientists are going to be doing here, where the helicopter is going to be landing, and even telling us a little bit more about the instruments and the science that it's going to be conducting on the surface. So for example, here's the list of the instruments and the different types of experiments they're going to be conducting here. With all of this available in this paper that you can find in the description, and this more recent paper that explores the actual landing site, identifying the specific geographic location, the reason for the landing there, and essentially creating relatively accurate maps for the potential first few days, mapping specific parts of the region, and also finding exact places where the landing can occur, and discovering some exciting areas that can actually be explored in the beginning. But here I guess it's important to understand what's already been done on Titan, what we know about it, and why it's such an exciting object. Way more exciting than Europa and the Clipper mission we've discussed in the previous video. So first of all, as you might already know, NASA has already been to Titan once. As a matter of fact, part of the Cassini mission that used to orbit Saturn included this right here, a tiny lander that would go into the Titan's atmosphere, and whose main purpose was to actually try to map and explore the atmosphere of Titan. Now interestingly, during its descent that took approximately 3 hours, it was also able to take a few pictures. And this is where basically the mystery began. The scientists had no idea what they're going to be landing into, and they had no idea if there was a liquid surface, a hard surface, or if the probe is even going to survive this landing. As a matter of fact, scientists initially thought that there was a global liquid ocean of methane and ethane, and that the probe is just going to sink. And because of this, they didn't even include anything that would require some kind of a drilling or some kind of a surface exploration, because they didn't expect the probe to survive. And the probe, known as Huygens, officially landed on Titan in 2005. You're going to see some of the images from the landing in a few seconds. But the probe itself was designed to either float or potentially land on the surface, because, like I said, nobody knew what's going to happen. And so if it was some kind of a liquid, it would just float around taking initial pictures. But there was hard surface, and these are the first images of the so-called rocks that are basically made out of different types of ices. Here's the landing itself. And so even though most of the experiments here were atmospheric, the probe overall was able to conduct some science determining what the surface is like as well. Although most of the science was really done because of two things: the landing itself, and also the various effects we see from the shadow of the parachute as it slowly lands on the surface. So it became clear to the scientists that this is definitely a hard object that does seem to contain some lakes, but for the most part there is definitely surface here to land on. But because these were the only images we had from the surface of Titan, very little else was known about it. As a matter of fact, Cassini, that orbited Saturn for 13 years, was unfortunately unable to explore the surface of this object because of the extremely thick methane atmosphere. And so this right here is really the best pictures we have of the surface of Titan, in this case created by Cassini's radar. And even this shows us that there are certain morphological structures resembling planet Earth, including things like dunes, lakes, mountains, and even features that resemble something that was swept by the wind. More importantly, there were even signs of liquid cycle, although in this case the liquid is probably either ethane or methane, not water. So basically it was raining here, but the rain was very different from what we're used to, because methane and ethane have very different liquid effects compared to water. All of the other features here would be also extremely different. For example, if there is ice on that water, instead of floating on the surface, it's most likely just going to sink to the bottom of the lake. And because Titan is really the only object we know of out there that has very thick atmosphere, that possesses some kind of a liquid cycle, and also seems to have other effects, including some kind of a geological effect, this was always the prime candidate for essentially exploring the idea of extraterrestrial life. But we had to find a way to land here and to explore the surface, conducting all of the science. Just using a telescope or some kind of an orbiter was not going to be enough. And so some of the initial suggestions called for some kind of a balloon mission, where the balloon would basically fly around the atmosphere, possibly landing once in a while, and conducting the science on the surface. But as NASA started to develop the idea of a helicopter, which by the way is also on my t-shirt right here, the Martian helicopter known as Ingenuity, similar ideas started to be developed to be possibly used on Titan as well. And because the measurements from Huygens probe established that the atmosphere here is actually really thick, possibly even 4 times thicker than the one on Earth, and also because the gravity here is much weaker, all of this suggested that using a helicopter would actually be much easier than anything else, because the flight here is so much easier than even planet Earth, making this a perfect object for a helicopter-based exploration. And as the mission was developed, more and more exciting news and exciting discoveries started to come out of old Cassini data as well. For example, there were several detections of unusual methane cycles that, at least on Earth, usually are produced by various types of life. The scientists have also discovered quite a lot of organic molecules, with certain types of molecules being extremely heavy, with a molecular weight of over 100, which did imply some kind of a complexity of chemistry on the surface. And as a side note, the only reason they only discovered molecules up to a molecular weight of 100 is because the mission was never designed to find anything heavier. Originally, the scientists did not think that even these complex molecules would exist in the atmosphere of Titan, which implies that there's a lot of complex chemistry going on here, with this unusual object very likely possessing all of the required energy needed to potentially host life. But obviously not life anything like here on planet Earth. The cycle here is methane and ethane. The temperatures here are super cold, about minus 180 degrees Celsius or about minus 300 Fahrenheit. But all of these conditions create perfect environment for unusual carbon ice chemistry, with things like methane and nitrogen clouds potentially creating all of the effects that are similar to the effects we observe on our own planet. Titan is really as alien of a planet as we can imagine, and if we actually find life here, it's going to be one of the biggest groundbreaking discoveries of the last few hundreds of years, allowing us to finally start answering the question of life out there, alien life, possibly on other planets around our own galaxy. But obviously the much bigger question is going to be raised if we find nothing here. Even though all of the ingredients are there, the signs are there, the actual composition, the liquid, the energy, the methane patterns, everything seems to suggest potential life. If we find nothing, that's when the mystery is going to kind of become more mysterious. And that's basically why the mission has been planned and why it's now definitely going to be happening in the next decade or so. It's actually going to be launching in 2027, but it is going to take some time before it reaches Saturn. As a matter of fact, the actual landing is planned for 2034, 12 years from when I'm making this video. But we do have a lot of detail about everything about this mission already. So first of all, where is it going to be landing? Well, the scientists decided to choose one of the craters located around the equatorial region of Titan. It sort of looks like this. It's approximately 90 kilometers in diameter and it's known as Selk. It's most likely an impact crater created by some kind of an asteroid collision, which means that during the collision it very likely brought up a lot of things from within Titan and spread it across a larger area very close to the rim of the crater itself. Which means that by investigating the location of this crater, it might be possible to investigate not just the surface of Titan, but also the internal part as well. A lot of the internal stuff probably came out during the collision. Although the actual landing is going to occur in the location known as the Shangri-La Dunes, extremely close to the crater, because the scientists think it might be actually safer to land here as opposed to the crater itself. And these are of course sand dunes created by some kind of a wind interaction on the surface of Titan, which by itself is already a pretty important scientific area that seems to have been created in the same way that dunes are created here in various deserts on planet Earth. And so by using some of the previous Cassini images along with the data from Huygens lander, the scientists realized that this was probably the best location for the rover craft to land. The craft that's going to be approximately 450 kilograms in weight, and that's also going to contain relatively large blades, approximately 1 meter across. And it's also going to be able to fly relatively quick, approximately 36 kilometers per hour or 22 miles per hour. All of this using nuclear energy. But once in a while it's going to land and stay on the surface, using some of its instruments that are described in one of the papers to essentially drill in, collect some of these samples, and then use the internal analysis instrument to conduct all kinds of spectroscopy, identifying exactly what's inside, but also specifically looking for life, making this particular helicopter the first to officially incorporate search for life as one of the more important parts of its mission. The last one was the Viking probe in 1976. And so one of its goals is to actually look for chemical biosignatures potentially produced by bacterial life that might be present here, but also exploring the active methane cycle that we know that the moon possesses, trying to understand exactly how it works and what it produces on the surface. And if there's no life found, it's also going to be exploring the prebiotic chemistry, potentially identifying the reasons why life did not form here and what prevents life from forming. In terms of its scientific goals, it's probably one of the most important missions of the last few decades, way more important than anything we've ever sent to Mars, Venus, or other objects. And the mission is going to teach us so much more about how life formed on planet Earth. And so essentially for approximately 16 Earth days, the helicopter is going to be flying around, collecting all of the pictures and all of the atmospheric data, then it's going to land and conduct a lot of chemical science for approximately 16 Earth days as well. And that's because a single day on Titan is approximately 16 Earth days. So during daylight, when there is a little bit of sunlight, it's going to be taking pictures and flying around. During nighttime, when it's really dark, it's going to be conducting chemical science. Although even during daytime, it's still extremely dark. The actual amount of light that Titan gets during, for example, noon, is actually less than 1% of what we get on Earth. And so even during the brightest day, it's still going to look like an extremely dark night on our own planet. Although one potential problem here that we cannot currently anticipate is the problem of rain. We obviously have no idea what happens if it does rain here, and what's going to happen to the helicopter if the methane or ethane rain starts to basically freeze on its surface. It might actually end the mission prematurely, or at least disable the helicopter from flying further. In other words, this is one unknown that we currently cannot prepare for. So at the moment, nobody really knows what kind of weather patterns we can expect on the surface of this beautiful moon. But in some sense, by going here and by exploring this object, it's like we're looking back on Earth billions of years ago. To some extent, some of the chemical signatures here resemble something that we think might have existed on our own planet, either before life formed or during the formation of early life, although obviously much colder. But more importantly, by exploring the area around this crater, we're also going to be able to explore the interior mantle ocean that might have released some of its content when this initial collision occurred and when all of the material from within Titan got deposited around the crater, leaving all of the chemical signs for us to explore. Moreover, this particular location potentially has biosignatures from any water-based life that might exist inside Titan, or any hydrocarbon life that might exist on the surface. In other words, it allows the scientists to explore any potential life that might exist either on the surface or within Titan itself, or at least signatures of previous life that might have existed here that should be deposited as very complex organic molecules that would be impossible to produce naturally, with a lot of other goals of this mission being more chemical in nature, understanding various cycles including various ethane, methane, and hydrocarbon cycles, and figuring out what kind of organic molecules exist here, how they were most likely formed on the surface, and what sort of geological processes play a role in creating the surface as we see it today. Because this is such an alien object, it's kind of impossible for the scientists to currently understand what they're actually looking at. Even these dunes right here are sort of created in ways we cannot understand. We know that there's wind involved, but because the gravity here is different, as is the atmospheric pressure, the exact process is still unknown. But at least for now, we don't even know what the mission is going to look like. This is just a preliminary concept, and so it's really only in the next 5 years that we're going to start seeing actual helicopter being developed, with all this possibly becoming more complex as new technology becomes available to create something even better. But at least for now, the scientists are really clear on the science goals, the objectives for this mission, and the location site, and everything else we're going to be learning about in the next 5 years before the mission launches. And so until then, thank you for watching, subscribe, maybe share this with someone who loves learning about space and sciences, check out that previous related video about the mission to Europa that's actually going to occur a few years before this one, and maybe support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.
Bye bye. So we're going to get a lot of space stuff in the next several years.
Yeah, 2024 is going to be a good year because you got Europa Clipper as well, due to land. Well, no, not landing, sorry. Analysing Europa. So that should be interesting year.
And what was that other gas or whatever that they said? Methane and ethane.
Yeah, I missed what he said as well. I heard him saying methane. I didn't catch what he said the other one.
How similar is ethane? Is that just a... I don't know. I have to look that one up. Might be frogs there.
Ethane is an organic chemical compound with a chemical formula I can't quite see it, CH6 or something, C2H6.
Oh, okay.
At standard temperature and pressure, ethane is a colorless, odorless gas, like many hydrocarbons. Ethane is isolated on an industrial scale from the natural gas and as a petrochemical byproduct of petroleum. There you go.
Wow.
C2H6, that's right, yeah, I couldn't quite see what I was reading.
So basically you could capture the atmosphere on there and use it as a fuel.
Yeah, if you had some oxygen to mix with it.
Yeah.
So, because methane is CH4, because it's one carbon, and then ethane is 2 carbons, so it's CH6. C2H6, sorry.
So I suppose that makes sense as well because they're talking about with SpaceX Starship can make methane on Mars, and that's what the engines use because it's 95% carbon, right? 9% carbon dioxide, 3% nitrogen on Mars.
Truth nerds, simply put, ethane is like methane, but with 2 instead of 1, and then follow propane, butane. Okay.
Ethane is the digital version of Thane.
Well, by the time we watch this, our time will be up.
Oh, quickly before you press play there, if you haven't seen Simon Dan's, he calls the channel Simon Run, isn't it? Cy Run Man, something like that. But he did a marathon.
Oh, okay.
Yeah. It's like a 3-day event, something like over, I don't know, 100 kilometers altogether.
Yeah, I did hear
so
about
if you get a
something
chance,
about that. Yeah.
yeah. So he did a video on that, and it was a bit of a challenge. Go watch it. It was pretty good. Yeah, he finished it. Yeah, he did really well.
Have you got a link for
Anyway.
that for the peanuts? While I'm.
Yeah, I'll find you the link now. Yeah, I can do that now. While you went. In the meantime, Terry, press play.
Okay.
Santos, or as he calls himself on YouTube, Mr. Astrotheology, is into almost every single spiritual gimmick that exists. He spends his time on YouTube giving what he thinks are genius lectures for his syncretism society and endorsing nonsense medical products that have no real evidence for actually working. This week I have found a lecture of his from 5 years ago which seems to be a culmination of all of his work. I simply had to dive in and take a look. Hello all and welcome along to another episode of Tinfoil Tuesday with me, Simon Dan. Thank you very much for joining me. Before we begin today, a massive thank you to the sponsors of today's video, Simon Dan, to get 15% off your first purchase of Raycons. Right, back to today's video, which, as I said at the start, is a look at one of Santos Bonacci's old lectures. Let's just dive straight into it, shall we?
So we will tackle the subject via energy and how energy can be used to heal. So if we grab the word energy, we'll have a look at that word carefully. We'll see that it's nothing but an anagram for green.
Is it?
No, it's not.
I don't think it is, Santos.
Okay,
Yeah,
so
we've got an extra Y there.
What do you see? Where do you see this? Look.
Double
There's
E.
a Y.
And
Where's he going to fit the
to
Y?
some giggles. Sorry. We put the Y on the end. Greeny.
So not an anagram then. Great, thanks.
Two E's then.
Green.
Where'd you get the other E from?
And
oh no, there is two E's, isn't there? Yeah. And
we'll see that
sorry, my bad.
Yeah, man.
the 12 petaled heart chakra is green. And it's the middle of the chakras. Here we have blue. Here we have indigo. Here we have violet, ultraviolet. And here we have yellow, orange, red, and infrared.
Ah, more pseudo babble.
Okay, so what we find is when it comes to colours, that the green is in the centre. Now, this is a torus field, and this is the only form that the universe knows.
Now, yes, the torus field does appear in nature quite a bit, but obviously there are more forms than just that.
Creator, which is the energetic. That's the energetic, the dielectric. Let's call that source creator, Krishna, Christ. Here is magnetism, and magnetism is motion. Mag in Sanskrit means to move. So this is rest, this is motion.
But you just called dielectric energetic.
That's the energetic, the dielectric.
And now it's rest?
So this is rest.
Come on, Santos, get it sorted.
And the effect of these two field modalities or action reactions is electricity, electrification.
That was some of the most potent word salad I've ever heard.
Okay, so this here is the neutral dielectric plane of inertia of every torus field. This is an atom, and this is our solar system.
Now, if you Google dielectric plane of inertia, the first 4 results are videos from Ken Wheeler, a self-proclaimed science genius that has more word salad dishes than Santos himself. So that tells you all you need to know there.
As above, so below. So all fields, or rather all motion, extrapolates itself out of this central counterspatial point, the 0 point, and galaxies work like this. You'll find atoms, galaxies, everything works like this. Everything is torus fields.
Well, galaxies aren't, and neither are atoms, so yeah.
And so as the lines come out from that inertial plane, where there is the principle of rest, or you could say inertia and acceleration. Okay, this is inertia and acceleration.
Inertia and acceleration, hey? So basically you're covering all the bases at once? What am I even saying? Of course you're not using these words with physics in mind, are you?
This is force and motion. Motion.
Of course, Santos is totally out of his depth here, because inertia means either at rest or remaining unchanged, which means, of course, you can be in unchanged motion. So, once again, Santos, contradicting yourself here.
And this is the electrical effect. In Bhagavad Gita, this is the internal energy of the Lord. This is the marginal energy of the Lord. And this is the material energy of the Lord, Krishna.
Right. Yeah, totally understand that.
And essentially, the creators of torus fields are step-down Krishnas. Brahma is a step-down Krishna. I'm a step-down Krishna. You are a step-down Krishna. Everything is expansions of source, of Krishna. So we are parts and parcel and minute parts of the one. Individualized in atoms. All is atom. Adam, atom. Same words. I can do a list of hundreds of words that go back to atom.
What? A list of 4-letter words all beginning with A, which are literally all different?
Okay, so this is the Adam torus, torso. And your torso, this is the heart. Okay, there are 12 petals here. 10, 11, 12. It's the heart chakra. 12. This is Jesus and the 12 apostles. Hercules and his 12 labours. King Arthur and his 12 knights.
Well, that one is still up for debate. Some stories claim that there are up to 150 knights on Arthur's Round Table.
And so what happens is blue shift. So if you look at your torso, your throat chakra is blue. Here is blue. And essentially these two colours are just a supercharged blue colour. So your torso knows the science. You've got blue.
Blue said, I think the cheese slid off this old boy's cracker.
Red shift at the bottom. So this is the base chakra. Here you'll have orange. Here you'll have yellow. And these are the colours of hell. And the bottom of your body is called a heel.
Okay, let me show you why this is ridiculous reasoning. If you go to the shops, they will try to sell you something. Sell, the act of exchanging goods or services for money. Seal is a water-type Pokemon. That is all.
Your heel or your soul, because this is hell. Hell is, well, you'll see this word in the word hello.
Oh my days.
Oh my God.
Hail. Help.
So any 4-letter word beginning with H then, Santos. Great. Makes perfect sense.
Helios. Helix. We're going to find that this is the double helix. This is everything from all kinds of energy. And what we're going to find that is that this blue shift is the healing part.
Whoa, what? The healing part. So hell again then, Santos, surely.
Yeah.
If this were a magnet, all magnets have poles, okay? What they call quote unquote poles. Now,
but it's not a magnet.
They're not really poles.
What?
Essentially, what's happening due to phase disparity of electromagnetic current or torrent, river,
phase disparity.
flow, flux.
Yeah.
I feel like Santos
What
just
is that
says
one? It's,
words and then he has a little word association game with himself for a few seconds.
So because due to phase disparity, you'll always have blue shift, red shift, anywhere, all atoms, they're not polarized, they have blue shift, red shift. Okay, so this is high frequency, high capacitance light, low frequency, long wave, low capacitance light.
It's like he's trying to tie literally everything in science together on one whiteboard. So Santos has loads more of this lecture to go through. So we're going to come back next week and see what other pearls of wisdom he has to offer. But for now, we are all done and dusted for another Tinfoil Tuesday. Let's see what Santos thinks about this.
Simon Dan, jackass.
Well, there we go. Thank you so much for watching. It truly is appreciated. If you enjoyed it today, please do consider smashing that like button. Oh, I can't believe I said smash the like button. Also, if you really enjoyed it, consider subscribing as well. We've got loads of videos on Santos, loads of videos that are similar on Tinfoil Tuesday playlist. Have a look at that. And then if the feeling takes you, please do share this as well. Just enough time to once again thank Raycon for sponsoring today. Remember, visit buyraycon.com/SimonDan to get 15% off your first Raycon purchase. I've been Simon Dan. Have yourselves a great week, and I'll see you all on Friday for the Flat Earth Fail compilation 41. Yes, we're carrying on. See you then.
It seems to be a thing that all we can do is go back on older flat earthers and just bring up what they started off with years ago. Bring back memories.
Tell you what, if my heart looks like that, I need to have a word with my cardiologist because there's something he doesn't know and he's not telling me. Either that or I'm dead. Yeah, petals, apparently. Yeah.
I got nothing.
There's nothing else you can say about him. It's just nuts. As well as being a really horrible human being, he really is a nasty little piece of work. He really is that Santos guy. Horrible.
Yeah,
horrible
the way
man.
he went off at Simon on his podcast thing.
Oh, I mean, you know, what he's saying to Simon Dan is nothing what he's been saying to other people. He's just nasty, horrible person.
Wow.
He really is. He's saying all sorts of crap about different
Had a
people.
split screen of this guy and Lindsay. Fun times. Oh, we're coming up to our 4 hour. I've got nothing to fill in a couple of minutes with.
Doesn't bother. Just end it.
Yeah, that's
Go
it.
early.
That's it.
Paul to be excited by that. He's dying to go to bed.
Well, I've got to get up at 6 o'clock in the morning.
I know.
Oh, we'll wind her up then. You can have your last 2 cents worth in while I just put the goodbyes out there. You been having any fun on Geo's or Jim's channel lately?
No, I haven't really had much time to do that sort of stuff lately.
How you going, Timbo? You learning anything over there?
I haven't learnt anything.
No.
I got to admit that some. Not so much on Geos, but I have found that some Globers are just as bad as the Flat Earthers.
Yeah,
they can be sometimes. Yeah.
Oh yes,
or
that
worse.
is a fact.
You don't want to mention any names?
No, I don't need to. They become evident.
You'll find, especially on Facebook, you'll find a lot of derp from Globers as well. If you hang around on Facebook long enough, on flat Earth groups, and they post things that's kind of like, "What are you doing?" No, it's just
Making it worse.
Yeah, quite often.
Yeah, occasionally it's better just to keep your mouth shut.
Yeah.
The guy that Reds had on debating Bev, a guy named Ryan or something, he kind of put his foot in his mouth.
What did he say?
Claiming that somehow or the other, with a Foucault pendulum, you can triangulate your position on the Earth. No, you can't.
With a Foucault's pendulum.
It's a Foucault pendulum. You can approximate your latitude. That's all.
That's
you can
about
do.
it. Yeah.
You're done. Yeah.
Try. Oh dear.
What? And is he a Glober? Is he a Glober that was claiming that? Was he?
Yeah, even Bev is smart enough to make fun of that.
Yeah.
Did you read emails that FE got, Fight the Flat Earth got from Santos, after Santos got some emails from some random guy? No, didn't see any of that. Oh well, I can't think of anything else. We got.
Yeah, if you look back at the story of what FTFE got, he got all kinds of emails. Like, I think he threatened him with his life, I believe, as well. Isn't that right, Tiny Captain? I think, didn't he? He's like threatening to kill him and all the rest of it. And the rumor is that Santos apparently is, I think he was on the run from the law at one point for something or other. I think it might have been drug offences or something. I'm not quite sure what the story is behind that. But yeah, it turns out he's doing all sorts of things, and he's just really unpleasant human being. Well, he's supposed to be into peace and love and tranquility and all this chakra crap. Nothing of it.
Okay, I can't do that. I was hoping I could do a trick for the end, but I can't. Oh.
Tax evading, that's it. Truth knows tax evasion. That's right. I knew it was something. I couldn't quite remember what it was.
I can't do that.
Well, the level is definitely not horizontal.
You didn't say it in the voice, though, Blue. I know you can't do it.
I'm not even going to try. No.
No, that's Farmer's job.
Yeah. And when I say how stupid can you be, it is not a challenge. It's a question.
Exactly. All right. Thanks, Timbo. Thanks, Alan. Thanks, Sal Pelmutta. Thanks, Matt. Thanks, Big Blue. Tiny Captain, Truth Nerds, Ball, Judy, Zebulon, Rimfondle.
I'm going to head off now. Good night.
Good night.
No.
Who else? Biggest Doggers, Clive, Harry Stew, Jinx Shoe, Spooky Bed Hair, Crumpy of Gunt, Facty. Who else did we have out there? I said Clive, did I? I can't find anyone else. No. I don't know if I've seen Judy out there. Oh yeah, Judy.
Yeah, Judy's been in.
Yeah, Judy was out there. Anyone else I missed? Truth Nerds. There we go. Armageddon's Fire. You just got in. Alright.
Okay.
I'm not going to hit the stop until I get me last word out.
Last words. Last words are for those fools who believe they've not yet said enough.
Okay. Good night, panel. Good night, Peanuts.
Good night.
Peanuts.
Good night.